Very good morning. Welcome, vanakkam, suswagatam. Everyone, do let me know. Can you hear me? Can you see me? This is your Baba HSP. And today we are going to start with Inorganic Chemistry of class 12. So first of all, I want to see green signal in the chat section that if everyone, can you hear me? Can you see me? Suswagatam. Very good morning to all of you. If I'm perfectly audible and visible to all of you, all my dear students, just show me the green hearts. Baba will definitely understand that I'm perfectly clear to all of you. This green signal is indicating that yes, you are ready for the class and I'm perfectly audible and visible. My dear students, now, this is really awesome. Now, what is the plan? Let me tell you the sequence, each and everything. There was lag in between. I think just for a second, there was lag, right? But now it's okay. I think it's perfect. Now, first I will start with coordination chemistry. Then I will tell you D and F block. And then I will come to the P block. Although P block I have told you in detail. But now today I will move with coordination chemistry. So if everyone is ready, show me fire in the chat section. And before that, my dear students, let me show you something that on huge demand of students, back on popular demand, 1 year IIT JEE and NEET UG subscription at flat rupees 5,499. You can see, my dear students, because number of students due to some reasons can be like finance problem, bank issues, number of things. They were not able to take that RM subscription. Now, so on huge demand of students, once again, this is just available for 5,499 rupees only for 1 year IIT JEE and NEET UG subscription. My dear students, you can see 88% off, biggest price drop ever. So you can help your juniors, your relatives, your classmates. Okay, fine. Now let's come to the sequence, how we are going to move kits. As I have told you, what I will tell you first, then second number, then third number, how I am going to move kits. I will move like this. Coordination chemistry, which holds a whole lot of weightage. This is very important, coordination chemistry. Each and everything I will tell you about coordination chemistry, which is given in NCERT or missing in NCERT. Then I will teach D and F block, my dear students. And after that, I will move with P block. So this is very important, and this one, and this is being least important. P block is being least important. Now everyone, you are agreed with me. I want to see once again the green hearts, and my dear students, likes are very less. My dear students, this is your Baba HSP. I will tell you each and every that thing which is important for your examination, this coming examination. Mark my words, kids. It holds a whole lot of weightage, and the tough things like how to find out number of geometrical isomers, how to find out whether the compound is optically active or inactive, how to get the color of complex compounds. I will cover each and everything, my dear. But I will start from the zero level to first rank. If yes, whatever I'm telling you, zero level, I will start from zero level and up to the first rank. I will move, and this is my target. So coordination chemistry, I will start from the zero level. DNA block, I will start from the zero level. If I agreed, everyone agreed with this. I have number of questions also. Printed questions, tough questions, which can be the rank deciding questions. I will tell you each and everything. But before that, if you're new to this channel, subscribe it right now. And all my dear students, it's your duty to mark your attendance in the form of hitting the like button, smash the like button, and then only I am going to start. And let me check it out how many of you are present. Let me see the chat, how many of you are present. So I am in front of this camera. Camera means this is your chat section. Yashwant, Bittu, Lavan, fast. Let me see how many of you are there. Akash, Shri, I want to see the chat section should be running very fast, kids. Yeah, PDF also I will send. But mark your attendance in the form of likes. Surya is there, Princess is there, Prasad is there, Ilamiti is there, Nature's Life, good morning. Fast, Alone Prince. Let me see how many of you are there. Ruthika is there. Surya is there, Dr. Sanjay is there, Sri is there, Akash, Sanya, Kashish, Adarbhat, Prashad, Ipshita, very good, Ipshita, welcome. Sri Prasanna is there, Kartik, Mada, Hari, Babita, fast, kids, fast. S. Surya is there, Tatu is there, Pandana is there, Guna is there. Very good. Harshita, China, Sanjay, everyone. I can see everyone. Hari is there. Wow, that's really awesome. So nice of you, kids. I can see everyone, almost all my dear students are there. That's really fantastic. So let me start. Kids. This is coordination chemistry, and this is your Baba HSP. Can you see? If you're new, if you don't know about me, I have done MTech from HBTI Kanpur in 2004. In 99, MSc topper, gold medalist, and JRF qualified. 25 plus years of teaching experience. It is 25 and produced AIR rank 1, 2, 3, 4, 5, AIMS as well as NEET. All those ranks. 26 plus years teaching experience. I have been teaching in this field. I'm over there for the 20 dear students, so you can understand what you're going to get over here. Those who are new, just subscribe this channel and hit the like button. You can see like, share, and subscribe. Okay, kids, can you see? Now let me start. So once again, the complex compound. If I talk about complex compound, and really it is complex, very complex. For example, if I write K4, Fe, CN6. Now these square brackets, which square brackets? Can you see? These square brackets, it indicates that whatever is inside it can't ionize. The part which is inside the square bracket can't be ionized. This is non-ionizable part. Non-ionizable part. And this boundary, you can say the boundary of the gate. Just like in your house, there is boundary wall, gated colony, you can say gated colony, or you can say Lakshman Rekha. Sita ji was there inside the Lakshman Rekha, then Sita ji was safe. So, non-ionizable part. And this is known as coordination sphere. Coordination sphere. This is known as coordination sphere. And whatever is outside this, these are known as counterions, and this is ionizable part. Ionizable part. This is being ionizable part. Now, the one who is inside this coordination sphere, there are two things. This is central metal atom. Central metal atom, CMA. What is the full form of CMA? Central metal atom. Central metal atom. This is generally from D block. D block. So once again in D block, when I teach D block, once again we will deal with this. Right, my dear students? Now, these are, you can say, the friends of CM. Ligands. Today we are using the word legends, but these are ligands. Ligands. Now, what is the relation in between central metal atom and ligands? The ligand is always in search of electron, just like it is CM. You know, CM, they are having too much money, but always they are having too many bank accounts and they are always searching for money. So it is electron loving, and those who can accept at least one pair of electron, they are known as electrophile. Keep on writing, they are known as electrophiles. If you know, if you can understand, keep on writing in the chat section. Electrophile, they can accept at least one lone pair of electron. They will accept in the form of lone pair at least one LP, at least one lone pair accept, and they are donor. Oh ho. Whoa, what I have written. Sorry, kids, sorry. This is not ligand. Wow, sorry. Electrophiles, these are central metal atoms. Arrow. Oh Baba, what I have written. Sorry, kids. This is all about central metal atom. This is all about whom? See, the arrow has gone wrong. Central metal atom. This is all about central metal atom. And the ligands are nucleophiles, lone pair donor. They are generally negatively charged and sometimes they can be neutral. Now let me see in the chat section that you got it or not. Have the correction has been done or not, kids? Correction has been done or not? Tell me, is it clear in the chat section? Is it clear in the chat section? Show me the green hearts. Actually, in the place of ligands, I have written about central. Is it clear, my dear friends? Do let me know. Everyone, do let me know. Baba has done the correction. Kids, I want to see in the chat section. That is it clear? Show me the green hearts if it is clear, kids. If it is being clear to all of you, show me the green hearts. Okay. So, now, these ligands can be same or they can be different. These ligands can be same or they can be different. They can be same or different. Same or different. Now, how this coordination chemistry is going to differ from double salt or normal salt. I will let you know. But before that, let me tell you one more thing about this. What is this? That is the most important thing. And what is the oxidation state? These two things I will let you know, right? But before that, moving towards that, let me tell you something. It's difference between complex compound and normal salt. Complex compound, if I talk about, then if you dissolve this complex compound K4FeCN whole 6 in water, this is being water, then what will happen? Now what will happen? Inside the water it will go and it will give 4 times K plus and FeCN whole 6, 4 negative. How many ions? How many ions? 4 plus 1, 5 ions. That means whatever is inside it, you cannot detect it. You have seen CID serial, Dr. Saluke, Dr. Tarika. They are just trying to identify what is given over there. So if somebody is having cyanide, the cyanide will not come outside the coordination this sphere, and you can never detect it. Are you getting my point? So you can't detect whether cyanide is present or not because it is not ionizable. It will just give the test of potassium. Potassium can be detected, but iron and cyanide can't be detected. Can't be detected even by detectives. But if I write alum, alum is being double salt. This is being double salt. If you put it inside water, what is the formula of alum? Everyone write down if you know potash alum's formula, if you know potash alum, because they can simply ask what is the formula of potash alum. You don't know the formula, you will lose marks. Potash alum. Now see, K2, just check it out, your answer is right or wrong. K2SO4 Al2 SO4 whole thrice 24H2O. Now it will ionize in the water K plus, sulfate negative, aluminium plus, like this. It will give the test of all the ions, means all the ions can be detected. The CID serial, Dr. Saluki and Tarika, they will detect. All the detectives can detect what type of ions. All the ions can be detected. Can be detected. Till now, is it clear? If something is clear, difference between double salt or normal salt, even you can take normal salt. Suppose in a glass, I'm going to dissolve NaCl. Let's have NaCl in water. So Na will get separated, chloride will get separated because of water's dielectric constant is very high. So it will ionize, it will go inside and it will weak that electrostatic force of attraction. They will get captured by water and they can be detected. Till now, is it clear? Show me the green heart so I can move ahead, kids. Your understanding is my first priority. So this is YouTube channel, and only the way to understand whether you are able to understand or not, just like if you see offline class, you will say, yes, sir, we got it. But here, I cannot see your faces. I cannot see whether you are able to understand. Only the way is I can see the chat section. Even I cannot read out. If I take my mobile and if I try to see your comments, then what will happen? Time will get wasted. So only one way, whenever you are able to understand, always show me the green hearts, and this is my duty. I will let you know. I will put each and everything in your brain. That's my power, you can say, or faith, knowledge, experience, whatever you want to say, you can tell that thing. But yes, I will make you understand. Now, first thing is that ligands. Let's understand ligands, types of ligands. Are you ready to understand types of ligands? Ligand. Now, see, my dear friends, just for a second. Ligands. Can donate at least, can donate at least one lone pair of electron. One lone pair of electrons. One lone pair means how many electrons? One lone pair means two electrons. Two electrons. So if I say, first of all, if I say neutral ligands, neutral ligands, neutral ligands. In neutral ligands, I will say water. Remember that their names are very, very important. If I say water, water's name is aqua. They call it aqua, aqua. Remember that. If I say ammonia, amine. So what we have to keep it in our brain, that there is double M. That is the most important thing, my dear friends. Amine is water. Aqua, amine. In amine there is double M. Amine, amine. Now I can say anything, any neutral compound, like I can say NH2, CH2, CH2, NH2. This is the most widely used neutral ligand. I will let you know how many types of names, how many types of representation for this compound is there. But see, this can donate one lone pair, this can donate one lone pair. So we will say that denticity is 1. Denticity is 1. What is the denticity? Denticity means donation power. But this can donate two lone pairs. Can you see two donor sites are there? So its denticity is 1 or 2. Definitely its denticity is 2. 2 is the denticity. Now, my dear friends, if I say that water can donate one lone pair, then its coordination number 1. Why coordination number? Because to the central metal atom, one coordinate bond it will form. But this will form two coordinate bonds, so its coordination number will be 2. Coordination number means the linkage capacity. How many atoms are coordinating with the central metal atom? So if I say there is central metal atom, so it's this part will be bonded, and this part will also be bonded. So its coordination number will be 2. This is coordination number, and that will be 2, and their coordination number 1. This point is clear, because coordination number is very, very important. If you can't understand the coordination number, you won't be able to understand anything. Now see, what is its name? Its name is ethylene. Focus, ethylene diamine, single M. Remember that, single M. And ethylene, no one is going to tell you this ethylene, although there is no double bond, it is saturated compound, but then also its name is ethylene. Once IIT has asked simple minute things, even IIT, they are going to ask, what is ethylene? This is ethylene diamine, no double bond is there. Now it's one more name is there. What's that? 1,2 diamino 1,2-diaminoethane, and its representation can be like this also, En. They can represent it like En, or they can represent it like N, like this. These are the number of representations for this compound, this ligand. This ligand is very, very important. If it is clear, show me the green hearts if this much is clear. Now, let me show you. If I write like this, compounds, number of compounds, neutral compounds are there. We can go with them like pyridine, like ammonia. But right now, let me focus on negatively charged ligands. Negatively charged ligand. Negatively charged ligands. Now, if I say Cl negative, so generally what you call it, Cl negative, you call it chloride. But here in this chemistry, they will delete E, and in coordination chemistry, they will call it chlorido. What is there? O. In place of E, they will put O. So if I say Br negative, what will you call it? Bromido. If I write Cn negative, you will call it cyanido. If I write like this, CO3, 2 negative, you call it carbonate. They will call it carbonato. We call this acetate. They will call it acetato. We call it C2O4 2 negative. We call it oxalate. They will call it oxalato. They will call it oxalato. We call it glycinate. NH2CH2 COO negative. Glycinate. They will call it glycinato. My dear friends, I think you are able to understand. Now see, some very, very interesting one. These many you are able to understand. Now if I say the SCN, one, this is donating, one is sulfur. And if I say NCS, now kids, this is thiocyato. Now this one, isothiocyanato. Remember that. Now if I call it N double bond O like this, nitrito N. And now if I write like this, ON double bond O, so I will say nitrito O, nitrito N. This is donating electron. Till now, if it is clear to all of you, show me the green hearts. I want to see that ligand's name. Are you able to understand or not? If yes, show me the green hearts, kids. Now, see, if I write like this, NCH2, N, 2 donor sites are there. Now, on this valency and this valency, if I add something, see, just try to understand. This is very, very special one. CH2, single CH2, COO negative, one more donor site, CH2, COO negative, one more donor site, H2, COO negative, CH2, COO negative. Now, my dear students, how many donating sites we are having? One. So, let me use another marker so that you can understand easily. 1 donor site, 2 donor site, 3 donor site, 4 donor site, 5 donor sites, 6 donor sites. Its name is fantabulous name EDTA. EDTA. Now 4 negatives are there. Ethylene, diamine, single am, diamine, tetraacetate. Now, if I ask you what is the denticity of this compound, could you please help me, my dear friends? What is the denticity of this ethylene diamine tetraacetate? Baba is asking one question. I want to see in the chat section. What is the denticity? My dear friend, do let me know what is the denticity. Fast, fast. It is polydentate. Sanya, yes. But what is the denticity? I want to see in the chat section, my dear friends. Denticity of this compound is how much? Fast, fast. Fast, everyone, do let me know what is the density. Yes. Wow, that's really fantastic. Really fantastic. Everyone is okay. Fantastic. 6. Now, what benefit it is going to get of the denticity 6 is chelating ligand. I would like to say it is chelating ligand. What do you mean by chelating ligand, my dear friends? It will go to the central metal atom and it will form a cluster, a ring, and it will provide stability because single ligand is having 6 donor sites. So it will go and give support to the central metal atom like this. Suppose if there is cobalt and EDTA is there, it will be like Dr. Octopus. So it will go to the CM and it will capture it from all the sides. Now, central atom will say, oh, great. Now see how it will go. Nitrogen, nitrogen, CH2, COO negative. Now, CH2, CH2 is there. I have not shown 2 CH2s. Can you see? Now, this will like this, COO negative. Now, COO negative. Now, COO negative, and it will give support, or it can capture from here, 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 it can capture from here. See, the central atom is getting support from everywhere. So it is very, very stable complex. It will stabilize the complex, stabilize the complex by forming number of rings. See, support, bonding. If more the bonding is there, energy will get released and stability will be there. So will stabilize the complex by forming number of rings, by forming number of rings. Now, after understanding this much, our next target is oxidation number, and once we are able to understand the oxidation number, then I will let you know effective atomic number. Are you ready? But finding the oxidation is till now we are moving with very, very simple topics, but these simple topics will definitely help you to understand one tough topic. Nothing is tough. Each and everything will become easy. Just try to understand. So now Baba is going to tell you how to find out oxidation number. Oxidation number of central metal atom. Now, for example, if I say I'm having K4 FeCN6, K4 FeCN6. Now, what is the oxidation number of this iron? Just try to understand. So, let me write down something over here. We know that sodium, potassium, they have +1 oxidation state. Cyanide has -1 oxidation state. So, 4 potassium are there, 4 into 1. This let us suppose X. Now, 6 is the coordination number, this is the coordination number, this is the place of coordination number that is not seen, and this is not cyanide, its meaning is coordination number. This is coordination number, coordination number. Now 6 into 1 negative charge minus 1, the whole compound is neutral, complex is neutral, complex is neutral, neutral complex, so is equal to 0. So just find it out. 4 plus x minus 6 is equal to 0. So x is equal to plus 2. Everyone got it? Is everyone able to understand? I want to see the coordination number in the chat section. So I'm going to give you another one. Another one, just find out for this. Cobalt, ammonia, coal 6, Cl3. Now once again, cobalt's oxidation state. I want to see in the chat section first. Before my solution, I want to see the answer in the chat section. Then it is going to benefit you. Otherwise, no benefit gets. So X, ammonia is neutral. You can see ammonia doesn't have any charge, neutral ligand. So plus 6 into 0 and minus 3 is equal to 0. So definitely X is equal to plus 3. Let me see the chat section. Let me see the chat section. How many of you have given the correct answer? Let me check it out in the chat section. Very good, very good. That's really fantastic, really fantastic. Now, my dear friends, you must be always thinking that what is the meaning of effective atomic number? What is that? EAN. What does it mean? Effective atomic number. Have you ever thought what is the meaning of this effective atomic number? Always we have seen the formula. Always we have seen the formula that EAN is equal to Z, atomic number, minus oxidation state plus twice of coordination number. How many of you want to visualize it? Show me the green hearts in the chat section if you want to visualize it. Then I will decode this formula. Otherwise, what is the benefit of the formula? No benefit, kids. You can't understand if you can't visualize it. No meaning. No meaning without understanding. Now see, kids, I will come back to this. I will come back to this. First of all, let me tell you, always understand, science teacher very crazy man. Science teacher very crazy man. Felt cold in night with cousin. Felt cold in night with cousin. This is very, very important line, my dear friends. If you don't know this line, you won't be able to understand D block. You will never be able to understand coordination chemistry. This should be in your heart. This should always be in your heart. What is the trick for this? Science teacher, very crazy man. Hey, hey, hey. Science teacher, very crazy man. Science teacher, very crazy man. Very crazy man. Man. Felt cold in night with cousin. Felt cold in night with cousin. With cousin. Now, if you remember this, you can easily remember atomic number also. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now, these two are exceptional configuration. Rest of others configuration also you can remember, you can learn, you can write. I will tell you. But right now I'm interested in what? If I say this chromium, see what is the pain of this chromium. Just see What is the pain of this chromium? Can you let me know what is the pain of this chromium? If I ask you what is the pain of this chromium, then the answer is chromium. We always see somebody who's better than us, somebody who's more stable than us. If I talk about doctors, if I talk about engineers, you'll see, wow, this is great doctor having bungalow, having Mercedes car. So I want to become like this doctor. So these elements, I always consider elements like human beings, and electrons like what, kids? If you know me, if you know Baba, electrons like money, and rest of the things I don't know. I know only these two things, money and human beings and their story. Human beings and the money and the story is moving like this. So they are always thinking about stability and money. We human beings always doing whatever we are doing either for stability or for money or for both. Am I right? First of all, do let me know. Everyone, do let me know. Whatever in today's world we are doing or anyone is doing, human beings, whatever they are doing, they do for what? Just do let me know. Human beings, whatever they are doing for stability, and they are doing for money. Some people are getting stability by donation of money, and some others are getting stability by gaining money. Am I right or not? If I talk about this stability, some people are getting stability by donating money, donation of money, and some others are gaining money and they are trying to get stability. Am I right or not, kids? If yes, this is the whole story of our world. If I am absolutely correct, I want to see the green signal. This is the only story of today's world. Today's world. Truth. And this same thing is happening with these metals. Same thing these metals are also doing. Suppose if I say that here is helium, neon, argon, krypton, xenon, radon. Now, my dear friends, some of you must be thinking, sir, we are not having too much time. Please, so don't tell us all these things. We are running with short of time, my dear friends. It's better to understand. If you understand one concept, then you can do hundred of questions, thousands of questions. You can't understand inorganic chemistry, you can't cram. You will lose your marks. Am I right? Am I right? If yes, this is not the story, this is scientific approach, and that you can understand easily. Now see, these are known as noble gas configuration. They are having noble gas configuration. So everyone wants to become like these elements 2, 8, 8 or 10, 10, 18, 36, 54, and 86. That is their atomic number. Now, D block element, just see if I tell you about chromium. This chromium is having 24 electrons. So, by donating how many electron it can have this configuration? The 18 and this 24. How much is the difference? It will donate 6 electrons and this chromium will turn out Cr plus 6. You must have seen K2Cr2O7. You must have seen K2CrO4. You must have seen CrO3. These are the complexes where chromium is having +6 oxidation state, and chromium is thinking, oh, now I have become stable, I have got the configuration like argon. My electronic configuration is same as that of argon, so this chromium is thinking very happy. But people told him, hey chromium, that is being neutral. Neutral means without charge, but you are charged one. You are having charge, you are carrying charge, you can't be stable like this. So this is not the stable condition, you are suffering with the disease. I've told you, element like human being, electron like money, and if anyone is having charge, charge means suffering with the disease, can't be stable. So chromium said, what should I do? How I can become more stable? Then people told him, this is D block. This story will come in D block. When I teach D block, I will come back to this. But right now we are dealing with coordination chemistry. So people told him, people told this person, hey chromium, your atomic number is 24. Why don't you do one thing? What's that? Why you can't try to become like krypton? Oh my God, how should I become like that? Everyone told him, you do one thing. You just approach a ligand named as CO. CO. This is one lone pair donor. One lone pair means how many electrons? 2 electrons donor. This is a neutral without charge. Neutral ligand. So you want to become like krypton. Krypton is having what atomic number? Krypton looks like this. How much? 36. How many more electrons you want to become like that? Just to let me know. This is 24 and that is 36. Write down in the chat section how many electrons it is in need of to become 36. How many electrons? It is in need of how many electrons to become 36? Fast, 12. So 12 electrons it is in need of. 12 electrons. So how many CO? How many CO? Write down how many CO? How many CO? To have 12 electrons, how many CO? How many CO? 6 CO. So 6 CO. So it will form a compound like this. CrCO whole 6. Now kids, chromium is having how many electrons? This chromium is having how many electrons? 24 of its own plus 12 of this. So this chromium is having 36 equivalent to that. This is also neutral, that is also neutral. Happy ending, neutral, neutral. So it is feeling very good. So it has gained electrons, 12 electrons. It got stability by gaining electrons and it is neutral also. Have you liked it? The story you have liked it, do let me know. That's why number of things like this are given in NCERT. I will tell you how many types of metal carbonyl compounds are given. Before that, let me move to back to from where we have started that thing so that you can understand, you can correlate each and everything, kids. Okay, are you ready? Is everyone ready, kids? See, we have started from here. effective atomic number, effective atomic number. So if anyone is asking what should be the effective atomic number of Cr CO whole 6, so we know the whole story. Atomic number of chromium is 24. Oxidation state 0 because no charge. This is being neutral. This is being neutral, no charge. So minus 0. That's twice of coordination number. What is the coordination number? 6. 2 into 6. So how much it will come out? 24 plus 12. It will come out to be 36. You liked it, kids? Till now you have studied number of times the effective atomic number, but I think today you got it. What is the meaning of effective atomic number? Now if I say, kids, if I tell you like this, just see to it that these are the elements. Science teacher, very crazy man, felt cold in night with cousin. Now, my dear students, what are their atomic numbers? Can you please learn it? 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So 24 plus how many CO? 24 plus 6 CO, and it has formed CrCO whole 6. Now see, 26 plus how many CO? I think how many CO? 5 CO. Am I right? FeCO whole 5. Table 36. Now 28. 28 plus how many CO so that it can become 36? Do let me know. 4 CO. So NiCO whole 4. It will always be like this. So I would like to say its EAN is 36. Its EAN is 36. Its EAN is 36. But this Magnus started shouting, hey, what should I do? My will not come 36. I'm being 25. So people said, okay, dear, don't worry. We will help you. If you are like this MnCO whole 5, just check it out. What is the effective atomic number? It can't become 36. See, 25 plus 10, 35. Its effective atomic number is 35. Now it started crying. What should I do? How I can make my effective atomic number 36? Now it's your duty to help him out. How he can become 36? Yay! Yay! So see, MnCO5 can do two things. There are two ways how to become 36. Caring is caring. Somebody told him, caring is caring. Caring is caring. To help your brother. How to help my brother? Everyone told him, do one thing. What's that? Right now you are MN1 Rand Mono Nale Anche Wana Rana Mono Nale Anche. Your brother is like this. Wana Rana Mono Nale Anche. 1, 2, 3, 4, 5. Now. Right now you are 25. Right now he is 25. Both of you. No, 25. Right now you are 35. Right now he is 35. Both of you are having EAN is equal to 35. You want to make it 36. What you can do? Caring is caring. You can help your brother, each other. So what is yours will be his. So now he is having how much? EAN 36. Now you will have how much? EAN 36. What is yours? That is yours. What is yours? That is yours. 36, 36. So this is known as dimerization. They will dimerize. Dimerization. Now second thing, what he can do, he can accept one electron, so it can undergo reduction. It can act as oxidizing agent, as an oxidizing agent. Now it will be like this, MnCO5 whole negative. Now if you want to cross check it, you can apply the formula. If you're not having faith, you can apply formula EAN. What is the oxidation state? -1, atomic number 25 minus oxidation state. Okay, 25 minus oxidation state plus, so I think, will it come by accepting one electron? It has to come like that. So it is minus, not minus. Oxidation state is negative. Minus will become minus 1 will become plus twice of 5. So how much it will become? 36 plus 10. Oh, not 36. 25 plus 10. 10 and plus 1. This is 1 also. Plus 1 plus 10. 36. Now see, too much time is taking in calculation, but this was easy. So it will act as an oxidizing agent. Till now, if it is clear to each and everyone, just check your NCERT. First of all, everyone, in your NCERT, one heading metal carbonyls are given. Everyone, it's my humble request, check your NCERT coordination chemistry, that each and everything like this, it is being given over there or not. Everyone just check it out. It's my humble request to each and everyone, just check your NCERT, and it is given like this only. It's Baba is making one request to each and everyone. Just take out your NCERT, do friendship with your NCERT, and just check it out in your NCERT. I'm checking your comments that you are sitting with your NCERT or not. Whatever I taught you right now, it is given on page number. Just go to your NCERT class 12th part 1. NCERT class 12th part 1 coordination chemistry chapter. Just check it out, coordination chemistry chapter. Laharika, thank you. Page number 136. Everyone, page number 136. Surya has written page number 136. Just check these metal carbonyl compounds are given over there or not. Everyone just check it out. Everyone, and then you will say, oh Baba, yes, this is really awesome, Baba. This is really awesome that it's given like this only, Baba. Everyone just check it out, your NCERT. It's given like this only or not. 136 page number. Everyone, Baba want to see that it's given over there or not. Now, I think you got it. You got it. Now, page number 136. Page number 136. NCERT. NCERT class 12 part 1 136 page number. Now, till now, if it is clear to each and everyone, let me ask some questions that you can solve those questions or not. Let me check it out. Ready for the questions based on this? Baba will make some questions right now. Question number 1. If I say MnCO whole 6 is A option, an oxidizing agent, B option, reducing agent. Write down in your answer only 2 options. Okay, write down C, both, D, none of these. I want to see your answer. Let me check it out. Who is going to give the correct answer? I want to see. I will wait for your answer. People are going for B. I can see they are going for B. Reducing agent. How you have given the answer? It's absolutely awesome, correct. Now, you can see effective atomic number of this. Z minus oxidation state plus twice of coordination number. Atomic number of manganese. Science teacher, very crazy man. Felt cold 0, 0, twice of 6, 2 into 6, 12, and this is 37. So, is it near to krypton? Krypton, that is noble gas configuration 36. To become 36, it has to donate. This has to donate 1 electron or accept 1 electron. Definitely, it has to donate. By donating, donation of an electron, it will become like MnCO whole 6 plus. Now its effective atomic number will change from EAN is 37. It will become EAN is equal to 36. So in this way, you can find out whether the thing will do what it is going to do or not. Now another question. Question number 2. Question is, which will undergo dimerization? Which will undergo dimerization? Dimerization. A, TrCO whole 6, FeCO5, B, MnCO whole 5, CO, CO, C, CO, CO whole 4. Now, 2 options are there. Which set will undergo dimerization? Let me check it out. Which set will undergo dimerization? These are the 2 sets. Let me check it out in the chat section. What you're going to write? Which will undergo dimerization? A. Some people are going for A. Some are going for B. Wow, mixed A and B. What is this, kids? You are playing game or you are attempting the question of NEET and JEE? What's going on, kids? You're not looking that serious because some are going for A, some are going for B. What is this? Where is the concept? Where being the concept? Now let's see. Let's see. Let's see. Its effective atomic number is how much? EAN is how much? 24 minus 0 plus 2 into 6. How much it will come out? 36. Its effective atomic number will be 26 minus 0 plus 2 into 5. How much it will come out? 36. They are stable. Why they should go dimerization? Here effective atomic number is 25 minus 0 plus 2 into 5. How much? 35, not 36. CO. Science teacher very crazy man, felt cold. Effective atomic number is 27 minus 0 plus 2 into 4. How much? 27 plus 8. 35. So 35. So just to gain stability, they will dimerize or not? Will they undergo dimerization or not? By dimerizing, they will gain stability or not, like Mn2 CO10. Now the effective atomic number will come out to be 36. This will CO whole 8. Effective atomic number will come out to be 36. Everyone got it or not? Is it clear? Show me green hearts in the chat section if you are able to understand. If you got it, kids. Show me the green hearts in the chat section if you got it, kids. Show me green hearts. I want to see green hearts if you are able to understand. Kids, do let me know. Everyone got it? Kids, don't talk. Everyone focus on studies. This is the time to change your future, to make your future. Yes, I know Tamil. I know Tamil. HSP. Sachin, Madan is there. JDSS is there. Wow. My all dear and student HSPN are there. Wow. Wow. That's really awesome. Laharika, Laharisha, Madan. Fantastic. Fantastic. Now see, kids. After telling you all these things, it's a time to move towards IUPAC nomenclature of IUPAC nomenclature. But before I move towards the IUPAC, kids, I want to see that how Baba is teaching. Write down some appreciating words. Show me some signals that how Baba is teaching IUPAC of complex compounds. Show me some colored hearts if Baba is really teaching good. Is Baba is really teaching goods? I want to see some colored hearts, kids. I'm teaching you even though I was not feeling well, kids. I was not feeling well, but then also I'm taking your class just to build your career, to make your career, kids. So Baba, what you have written, write down properly. We cannot see, Baba. We cannot see what I have written. What I have written, kids, do let me know here. What Baba has written, do let me know. IUPAC of complex compounds. Now, my dear student, today Baba will tell you in such a great way so that you will never forget. Now, see, kids. See, just try to understand what are the difference in between these compounds. If I write K4 FeCN6, another compound, if I write like this, CO ammonia whole 6, Cl3, and third compound like this, Ag ammonia whole twice Ag CN2. These three type of compounds, can you see any different kits? A, B, C. If you are able to understand the difference in between these three types of compounds, definitely you can do anything. No difficulty you will feel in writing IUPAC name. If you are able to understand these three compounds, just see. In our country, we say Sita Ram, ladies first, gents later on. Am I perfectly audible and visible, or lag is there, kids? Am I perfectly audible and visible, or lag is there, kids? If yes, then show me the green hearts. If I'm perfectly audible and visible, show me the green hearts, kids. Lag was there, okay. Lag was there. Now see. So if I say that we will write cation first and anion later on. First the cation and then anion. Can you see? Cation first, chemistry, in chemistry, cation first and anion later on. This is anion, this is cation. So this is cation, and here the complex is negatively charged. Complex is negatively charged, right? Can you see complex is negatively charged? Now here complex is positively charged and that is being negatively charged. And here this is positively charged and that complex is negative. Complex is positive and negative. Can you understand this thing? What where I'm focusing, kids? The complex is negatively charged. At this point is my focus. Here the complex is positively charged. This is point of focus. And here the complex is positive as well as negative. Are you getting my point? Now, what I want to tell you, just try to understand. If complex is having negative charge, remember what I am going to tell you, kids. If complex is having negative charge, then the central metal atom says that write down my official name, and I am like no more in the world because I am on the second position. This is first. Then I'm coming second in my life. So put 8. Just be people right. If somebody is no one in this world, late Ramu, late so and so. So they are saying put 8 in front of my official name. Are you getting my point? Who is saying? Who is talking like this? Who is being talking like this? Central metal atom. Now its name, official name plus 8. Now here it is positive. He has got positive attitude. He will not talk like this. This complex what got negative attitude. That's why he's talking like that. But he has got positive attitude. So we will not write thing like that. Now here this is positive. He's saying no problem, but he is negative. So he's saying write down my official name and add 8. Add 8 because I am having negative approach. He is having negative approach. If the complex is having negative approach, then the central metal atom says write down my official name and add 8 after that. Got it? If this thing you are able to understand, the whole IUPAC you can do without any error. because this is the most important thing which holds a hell lot of weightage, and where most often people are going to make mistake. This is clear. Show me the green hearts. Let me move aside and just see. You can take the screenshot of it. If this thing is clear, kids, you can do each and every question. You will be able to do each and every question, kids. Now I will show you. I will show you also. Let me check it out. Let me check it out if this thing is clear or not to kids. Everyone do let me know. Is this clear? Is it clear to each and everyone, kids? Yes. Yes. Do let me know. Yes. Now, kids, everyone is not participating. Everyone is not participating. Now see. Now see South Sea. South Sea is there. Is South Sea there? Now see. The first compound K4 FeCN6. Just see. K4 FeCN6. K4 FeCN whole 6. Now, whenever you write IUPAC of this compound, do some homework. What's that? Rough work. What's that? Oxidation state of central metal atom. 4 into 1 plus x minus 6 is equal to 0. So, x is equal to 2. But here the oxidation state will be written in Roman numbers. Roman number is 2. That is Fe2. Now, iron is saying that this is coming on first position. So write down its name, but this number should not be indicated, will not be mentioned in the IUPAC, will not be mentioned. Who will not be mentioned? Number of this counter ion's number should not be mentioned, but counter ion's name will be mentioned. Now we'll write potassium. First letter can be capital or it can be small. This letter can be capital or it can be small, doesn't matter. Now this iron is saying, central metal atom is saying, my official name, and add 8. Official name plus 8 plus oxidation state. Now, before writing my name, write down the one who is donating electron to me. Central metal atom says, before writing my name, my ligand's name should be written first. They are like legends. The ligands are like legends. Write down their number first, their name first. So, ligands are like legends. So their names are more important. So write down their names. So potassium, hexa, coordination number is hexa, cyanido, ferrate, official name ferrum, not iron, ferrum. So it will become ferrate 2. First name Baba has written successfully. If you are able to understand, Baba has taken too much time while writing this name. I have taken too much time, but I promise you that I have told you each and everything. Just show me green hearts. If successfully you got this name, it has gone to your brain, kids. This name has gone to your brain successfully. Baba want to see. Hitkeshwar, I will let you know. I will let you know. But right now, do let me know that everyone, those who are spammers, don't worry. You show the green heart, spammers will go away. They will run away. Definitely, they will run away. Show me the green. And kids, hit the like button. Everyone hit the like button. Till now, if you have not done that, let's do everyone. Do not smash the like button. Smash it right now. Wow. Now, see the second name. See the second name. If right now the complex was, here the complex was positively charged or negatively charged? Negative charge complex. This complex was negative charge. Now, another complex. Just see. CO ammonia. Okay, before that, let me tell you the same complex. If the complex would have been given like this: A4 Fe CN whole twice Cl2 Br2. Now, same iron is having two oxidation state, but how you would have written the name? Potassium. Now, the ligands are having different types. So their names will be written in alphabetical order. So bromo, dibromo, dichloro, dichloro or chlorido. Chlorido is better. Chlorido, dicyanido, ferrate 2. These names will be written in alphabetical order. Is it clear, kids? Alphabetical order. Alphabetically. These names will be written alphabetically. I think this is clear to all of you. If each and every point is clear, kids, always keep on showing green hearts or thumbs up so that it should remain clear. Clarity should be there. Now, see. CO ammonia whole 6 Cl3. Now you can see this complex is positively charged. So how? First, this hexaamine, no space will be there. Hexaamine, cobalt will be written as cobalt, but the homework should be done. What's that? Its oxidation state X plus 6 into 0 minus 3 is equal to 0. So X is equal to plus 3. So cobalt 3 chloride. I hope this is also very much clear to all of you, that everyone is able to understand it. Now here comes, if the complex is having positive as well as negative charge, then how we are going to do that compound? Just see, this one gets Ag ammonia whole twice Ag CN2. Now see, first find out the oxidation state. This state X plus 2 into 0 plus X plus 2 into minus 1. The whole compound is neutral, so 0. The value of X will come out. X, 2X, this is X, 2X, this is 0, that is minus 2. is equal to 0. So 2x is equal to 2. So x will come out to be 1. This is done. We're able to understand this much. Now see, this is positive charge. So its name will be written as silver. And that is being complex, being negatively charged. So its official name is argentum. Argentum will be written as argentate. Argentate. Now start writing IUPAC name. How will you write it? Diamine. Diamine. Silver 1. Silver 1. Dicyanide. Dicyanide. Argentate 1. Argentate 1. Now, how many of you got it, kids? Do let me know in the chat section, green hearts, that yes, you got it, so that I can understand that I made it clear to each and everyone. These are the fundamental things. If you got it, show me the green hearts, kids. Fast, 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 kids, fast. I want to see your answer, my dear students. I want to know that you are able to understand. Hey, your green hearts. Now this time, everyone is perfect. Perfect. Gets perfect. Wow. Now, the father of coordination chemistry, Werner's coordination theory. Baba is going to tell you Werner's coordination theory. Are you agreed, or are you ready? Are you ready for the Werner's coordination theory, kids? Werner Baba, Werner Baba, Werner Baba, Werner's coordination theory. Kids, these are easy things. Once I tell you all these easiest things, I will let you know the toughest things. Valence bond theory. After that, color, how to find out color of any compound. Then, just think of how to find out total number of geometrical isomers, optical isomers. Then, Don't-Teller effect, distortion, then trans effect, then synergic bonding. Oh my God, lot of fun, lot of marks. Now see, Werner's coordination theory. Just try to understand. He has taken well-known, famous example, most studied example. What's that? Famous example. Or you can say most studied example. What's that? Most studied example, my dear students. What's that? Can you please let me know what's that? That is CO ammonia whole 6 Cl3. This is his most famous example, kids, he has taken, for which is known. Now, my dear friends, just see what he said. He said every central metal atom, this is central metal atom, is having fixed type of secondary valencies. Like the central metal atom is having 6 secondary valencies, and the one who is outside this house, they are having primary valencies. Just see, if I say every CM, let me put some twist. Just try to understand. This is movie. This movie has nothing to do with anyone whose character is resembling with this movie. If anything is found to be like that, that is being fictitious. Baba has told you nothing to do with the reality. Baba is going to show you one movie. Are you ready? That in movie, there is one CM. CMA, not CM, CMA. CMA. The CMA is having what to say, wife, secondary valency. Wife is inside one, and that is, you can say, the girlfriend. Okay, wife and girlfriend. Wife, and this you can say girlfriend. Yeah, and this VF, that is, this is VF. Okay, should I put character or should I not put character? If you want to see the characters like this, show me green hearts. If you don't want, show me fire. Then I will move like that. Let me check it out. If you say, then I will make a movie. If you're ready for the movie, then green hearts. If you're not ready for the movie, fire. Let me check it out with what you want to go. Fast, kids. Fast. So fast, kids, fast. Wow, now I got it. So I got it. Fast, kids, fast. Very good. Now see, Werner said every CM have fixed number of WF. That what Werner said? Werner said, point number one, every CMA has specific number of fixed secondary valencies. Now in this movie, this is primary. This is primary valency and this is secondary valency. Can you understand? This is secondary valency. You can understand why it is being secondary. Secondary valency. Can you understand, kids? This is being secondary valency and that is being primary valency. Now definitely no need to remember why it is being secondary. This is just movie. Once again, I am telling you, it is in movie only, not in real life. So please, kids, this is not in real life. This is movie only. This is being primary, and this is being secondary. Who is going to spend money of CMA? I'm not going to tell what Werner said. You tell me who will be responsible for expenditure or spending money of this CMA. You let me know. Then I will tell you what Werner said. Who will be responsible for spending? Who is going to spend money of the CMA? Do let me know. Yes, Vasu, Dinan, you got it. Now see, kids, I haven't told you what Werner said, but you are able to understand. That primary valency are responsible for oxidation state. Now let me write down on another page. I am telling you less, you are able to understand more. I'm telling you less, you are able to understand more. Central metal atom, secondary valency, primary valency. Now, this primary valency is responsible for oxidation state. That its oxidation state is +3. Who is responsible? X plus 6 into 0 minus 3 is equal to 0. So X is +3. Whatever the money he has lost because of that valency, that primary valence. Now, who will be responsible for counting the votes or making the house structure? Who will be responsible for that? Just do let me know. This one, secondary valency is responsible for, secondary valency is responsible for coordination number, because its number in the house family member will be counted. That number will not be counted in the family member because that is not inside the house, that it's outside. Secondary valency is responsible for coordination number, for giving shape of the molecule, responsible for shape of molecule. Now, do let me know what Werner said. I am not going to tell you. You have to tell me who can go anywhere and has freedom to move, to go with anyone, can form bond with anyone. The secondary valency or the primary valency means who is ionizable, who is having more freedom. Do let me know. Then I will tell you what Werner said. Then I will let you know what Werner said. The primary valency is having freedom to go anywhere, or the secondary valency? Primary valency. So Werner said primary valency is generally ionizable. Primary valency is generally ionizable. Primary valency is generally ionizable. Now, why this generally ionizable? I will let you know. What is the meaning of this generally? Here is the twist. Generally ionizable. Point to be noted, my lord. That is important. Secondary valency is non-ionizable. Secondary valency is non-ionizable. Now, see kids, after understanding this is all these things are told by whom? Werner. Werner said all these things. Now, kids, how many of you are thinking that Baba made it easy with the help of story? If yes, show me the green hearts. If this theory, then I will tell you how to solve the questions and what type of questions will come. But if you understand that Baba has made it easy, no need to revise it, show me the green hearts. Kids, don't write anything else. Just focus on studies. How much efforts Baba is putting over there. And hit the like button. Likes are less. Make them 400 at least. Tausi, very good. Ipshita, very good. Really nice. So nice of you kids. Now, even though today Baba is not feeling well, but then also Baba is telling you each and everything in detail so that you can understand, kids. This is really awesome. Really awesome. Now, see, kids, try to understand it. This generally word is very, very important. It is mentioned in the NCERT also. See, if I tell you that I am having these many complexes, just see how many complexes. Complex number 1, complex number 2, complex number 3, complex number 4. Now, focus over here. If I write down CO, ammonia, whole 6, Cl3. And if you add excess of AgNO3 to this, AgNO3 to this, how many white colored AgCl PPT you will get? You will get 3 moles of AgCl, right? White precipitate. Okay. Tell me one thing. If you are able to understand, who can take the position? This secondary valency can take the position of primary valency, or primary valency can take the position of secondary valency. Primary valency can take the place of secondary valency, or the secondary valency can take the place of primary valency. Do let me know. I haven't told you what Werner said, but you do let me know who can take place of whom. Primary of secondary. Vasu, very good. Now see kids, all these things I have never mentioned, I have never told you, but you can understand primary valency can take place of secondary valency. Primary valency can take place of secondary valency. Primary valency can take place of secondary valency, whereas secondary valency cannot take place of primary valency. That means primary valency can go over there, but secondary valency is not allowed to come over here. What is this point, kids? Really awesome point. Really $1,000,000 point, kids. Now see. If I write here CO ammonia whole 5. Why ammonia whole 5, kids? Why not 6? Why not 6? Why not 6, kids? Because central metal atoms coordination number is 6. It cannot have more than 6. That is fixed. So one ammonia has to go out of this world. Ammonia, only 5 ammonia are there. Now this chloride is in double role. It's to understand this chloride is in double role. Double role chloride. Why double role, kids? This chloride is acting as primary valency plus secondary valency. It is responsible for oxidation state. It is responsible for coordination number. Oxidation state, coordination number. So it is in double role. This is in double role, kids. Double role. And it is not ionizable. Not ionizable. And that's why I mentioned one point. What is that point? Just see. Primary valencies are generally ionizable. Generally ionizable. Now, you can understand why I have mentioned that point, kids. Now, you easily correlate. Now, if I add excess of AgNO3, now it will give you just 2 moles of AgCl white PPT. Hope that is very much clear to all of you. Very much clear. Now, if I write down one compound like this, CO ammonia whole 4 Cl2. Now 6, 1 chloride is there, only 1 ppt of AgCl, only 1 mole. If I write like this, get C, CO ammonia whole 3 Cl3. Now all the primary valencies are inside, and if you add AgNO3, will you get white PPT? No, sir. No white PPT. No white PPT. Now, if they are asking out of these 4 molecules A, B, C, D, which will have maximum colligative property? Solution chapter. Maximum elevation in boiling point, maximum depression in freezing point, relative lowering of vapor pressure, osmotic pressure. So maximum boiling point will be off. This one will have maximum CP, maximum colligative property. because if it is going to ionize, 3 molecules plus 1 molecule means 4 particles completely ionizes, then the value of I will be equal to N, and N is equal to 4 particles. Got it? Now, if they are asking which will have maximum conductivity, electrochemistry chapter, maximum number of ions, maximum responsible for conductance, maximum conductivity also, kids. Are you getting my point? Everyone. Now, is this thing clear to all of you? Then Baba is going to move towards valence bond theory, hybridization, the most important thing. But before that, let me know, are you ready? If yes, Baba want to see the fire in the chat section. If it is clear, till now it is clear to each and everyone. Do let me know. Everyone. Latha, Natalia, HSP, HSP, Sachin, it's Neha. Okay, I will give you question, right? First of all, let me give you question and I will move. Okay, so questions. Just see question. See the question, good question. I am going to make one very good, fantabulous question. CO, ammonia, whole 5, Cl. This is the compound. Ammonia whole 5, Cl 3. On reaction with excess of AgNO3 will produce how many moles of white PPT AgCl? Options are A option 0, B option 1, C option 2, D option 3. Do let me know. What's your answer? Let me check it out in the chat section. What's your answer? 2. Everyone is saying 2. Oh my God, so fast, so fast, so fast. Let me check it out. How to write it down. Hey Baba, the kids are very fast. So I have to make inside 6 CO. First preference I have to give to ammonia 5, 1 chlorine and 2 chlorines outside. Okay, 2. Oh Baba, very good. You got it. You got it. So no need to give you anything. You can do all the questions. Your fundamentals are very strong right now. Very, very strong. So you can do any question, kids. Any question. Now should I start valence bond theory? Everyone do let me know. Show me the green hearts if you are ready for valence bond theory. BVT. If everyone is ready for BVT, valence bond theory, kids. Now kids, to understand valence bond theory and to go with hybridization, only we have to understand one thing. What's that? What's that, kids? We have to understand spectrochemical series. Spectrochemical series. If we understand the spectrochemical series, we can do anything. And second thing is required electronic configuration. Electronic configuration of D block. Are you ready for this? 3D series, 3D series. So let's deal with this so that we can do any question of this world. We can do any question of this world. Are you ready, kids? Are you ready, kids? Everyone ready? Very good. Now see, spectrochemical series is experimentally determined series. Spectrochemical series is experimentally determined. Experimentally determined. Spectrochemical series. Everyone, right now you have to focus. So let me write down first line. First line, weak field ligand, iodide, bromide, SCN, chloride, sulfide. Now, one thing is missing in NCRT, that is nitrate here. So I have written nitrate over there. Now, second line, Baba is going to write down second line. Why I am writing like this? So the strength is increasing in this order. Strength is increasing in this order. They all are weak field ligands. After that, I'm going to write over here fluoride, hydroxide, oxalate, oxalate, hydroxide, water, NCS. Now, if I talk about Tamil Nadu board, in Tamil Nadu board, urea is mentioned over here. Urea is also mentioned over here. So all these are weak field ligands. Weak field ligands. Before I move towards one more line, but let me move, then I will tell you, otherwise you won't be able to understand. So let me write down the last line, last but not the least, very, very important line. What's that? EDTA. EDTA. EDTA ammonia, EN, CN, CO. One thing is missing in NCRT, that is being nitrite, nitrite, NO2 negative. Now this line, last line is of strong field ligands. Strong field ligands line, gets this line is of strong field ligands. Are you getting my point, what I am telling you? Last line is of strong field ligands. Now kids, these are being strong field ligands. Shuffle. Now how to learn it? How to remember it? Are you ready? Now see. Indian bro Sachin. Everyone say Indian bro Sachin's child. What is the name of child? Tara. Indian bro Sachin's child, Tara. Everyone say, I want to see in the chat section. You have to write down Indian bro Sachin's child, Sarah. Indian bro Sachin, 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 Sachin. Neha, Neha is over here. I will tell you Neha. Sachin, Indian bro, Sachin's child, Tara. Nitrate, 8, nitrate, 8, nitrate, nitrate. The night ate something. Ate something. Indian bros such as child Sara. Nitrate, nitrate, nitrate. Indian bros such as child Sara. Everyone say, I want to see Indian bros such as child Sara. Wow, Sahana, welcome, welcome, Sahana. Indian bros such as child Sara. Oh my God. Sahana has written the whole trick. Indian bros such as child Sara is fond of, is fond of, is fond of. See, is fond of, is fond of, is fond of, oxalate, oxalate, is fond of, oxalate in water with nachos, in water with nachos, nachos. Everyone say, Indian bro, such is child Sara nitrate is fond of oxalate in water with nachos. Educated Ammi or educated Neha, educated Neha, educated Neha, educated Neha is teaching English, is teaching English in Canada and Colombia, in Canada and Colombia, Colombia. I hope that till now it is clear to all of you. If yes, till now it is clear to each and everyone, I want to see the green signal in the chat section. Then I will tell you something more. Indian bro, such as child Sara is fond of oxalate in water with nachos. Educated Neha teaching English in Canada and Colombia. Colombia. Now, hit the like button if you liked it, kids. Those who are new, smash the like button if you're really enjoying it. The tough thing is becoming easy, and in this way, Baba will tell you each and everything will become clear to all of you. Now, see, kids. Let me something tell you the gray part of this, the tough part of this. Just see. Just see. Everyone. Just look, just look, just look. 3 lines, 1, 2, 3. First line, da da da. No. It's very dark. So let me make it a small one. First line, da da da. Second line, na na na. Third line, ha ha ha. 3 lines. Everyone in your brain, draw 3 lines. Now write down by yourself. Indian bro. Indian bro. Sachin's child. Sara. Nitrate. Indian bro, Sachin child Sara nitrate is fond of oxalate. Here is urea. Let me write down urea. Not given in NCERT. Is fond of oxalate and water with nachos. Have you written like this? Now, you must be thinking, Baba, why you are writing again? I will let you know. Educated Neha is teaching English in Canada and Colombia. I hope that this much is in your hippocampus. If this much is in your hippocampus, let me tell you one thing very clearly. This line is of strong field ligands. I would like to say these are being strong field ligands, right? These are being strong field ligands, and they are being weak field ligands. They are being weak field ligands. Till now, is it clear? All they are treated as being weak field ligands. But there is one twist. There is one twist. What's that? My dear students, these two, oxalate and water, just focus on oxalate and water. My dear student, just focus on oxalate and water. Remember that they will change the game, and examiner will ask question from these two only. The examiner will ask all the questions of hybridization, or if I talk about color chemistry, that examiner is going to ask question from these two only. That these two, when they are present with cobalt 3 plus, remember that when they are present with cobalt 3 plus, with whom I am saying, kids, do let me know with whom. With the cobalt 3 plus, cobalt 3 plus, they will act as strong field ligand, will act as SFL, strong field ligand. Let me write down this point separately. Although oxalate and water are being weak field ligands, but with cobalt 3 plus, remember that 3 plus, they will behave as strong field ligand. One point, this point you have to make very clear so that you can get full marks. These are the game changer. Now, how will you remember it? How many of you want trick for this so that you will never forget and you can remind, you can get it over there? How many of you want to have trick for this? Show me the green hearts. Everyone show me the green hearts, then Baba will give you the trick for this. To remember it, to learn it, Baba will give you trick only in that case. Do let me know, kids. Everyone, do let me know. Okay, just see. You know Mahadev. You know Mahadev. Have you heard the name of Mahadev? Shambhu, Shiv Shambhu, Bholenath, Shiv Shambhu. Cobra. You know Cobra, Tridev's Cobra. Have you heard the name Tridev's Cobra? Have you ever heard the name Tridev's Cobra, kids? So remember that this is Cobra of Tridev. This is the trick. Tridev's Cobra. You remember that Nandi cow or ox. Nandi ox and Ganga means water. So with Tridev's Cobra, Nandi is ox, and Ganga is water. They have become successful. Successful means what? Supple, strong field ligand. This is the trick, kids. This is the trick. You liked it or not? Do let me know, kids. Fantabulous trick Baba has given to you. Do let me know, kids. Do let me know, everyone. With Tridep's cobra, Nandi, that is ox, and Ganga, that is water, has become successful. Otherwise, they were failed. They were weak. They were weak. But Tridep's cobra, Nandi, that is ox, and Ganga, that is water, has become successful. You liked it? Show me the green heart, kids. This is the game changer one. This is the game changer one. Do let me know, kids. Everyone, do let me know. If you liked it, if you like this trick, kids, do let me know in the chat section that yes one. You are able to understand. Very good. Very good. That's really fantastic. That's really fantastic. Really fantastic. Now, let me go back to this. Ammonia is strong field ligand. Ammonia is being a strong field ligand. It is being a strong field ligand, but with coffee man nickel, CO2 plus, Fe2 plus, Mn2 plus, Ni2 plus. Coffee man nickel, it will act as weak field ligand. Who? About whom I am talking, kids? I am talking about ammonia. Ammonia with all these will act as weak field ligand. Remember that. Although it is being a strong field ligand, but with coffee man nickel, remember that coffee man nickel, it will behave as weak field ligand. This is clear. Now we can do any question. We can do any question if this much is clear to all of you. Now see how to solve the question. If I say, kids, that I am provided with cobalt, ammonia, whole 6, 3 plus, or if I am provided with cobalt, cyanide, whole 6, 3 negative, or I am provided with cobalt, water, whole 6, 3 plus, or I am provided with cobalt, oxalate, 3 negative. In all these 4 compounds, they all are a strong field ligand or weak field ligand with cobalt. For cobalt, they all are, just to let me know, they all are being a strong field ligand or weak field ligand. Do let me know, kids. I'm talking for cobalt, not for everyone. For cobalt, all they 4 are strong field ligand or weak field ligand. Do let me know in the chat section. All of them, they are being a strong field or weak field. Write down in the chat section. Sachin, HSP, strong field ligand. Very good. They all are being strong field ligand. SFL, 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 SFL. Now, someone who is not having this trick, if anyone is not having this trick, that student will definitely treat this water and oxalate as the weak field ligand, and that kid is going to get failed. That student will definitely get failed for these 2 examples or not, kids. Do let me know. That student is definitely going to get failed. If the person is not having this trick. Now, my dear student, anyone's, you can find out. First of all, see whether cobalt is in +3. In all these, just check it out. Cobalt is in +3. See, cobalt is in +3. finite 6 negative 3 negative x minus 6 is equal to minus 3. So x is equal to plus 3 plus 3. That is very, very important. Plus 3 PO x 3 into minus 2 is equal to minus 3. X is equal to plus 3. Got it? Now, once you can find out what the hybridization, you will get the hybridization of all those. Now, just try to see what is required. First, we need cobalt's atomic number. How to find out cobalt's atomic number? Science teacher very crazy man. It may be given or it may not be given. Science teacher very crazy man. 25 felt cold. 26, 27, 27. So 27. Now what you are supposed to do? Just reverse the number. Reverse the number. Reverse it. Reverse it. 27 by reversing will become 27 by reversing will become 72. Are you getting my point? 72. 3d7 4s2. Got it? This is cobalt. 27 atomic number. Reversing it 72. 3d7 4s2. Now cobalt 3 plus. How to write down cobalt 3 plus? Cobalt 3 plus will be losing 2 electron from here, 1 from here, 3d6, 4s0, 4p0, 4d0. My hero till now. Everyone got it till now? Just to let me know. I want to see in the chat section till now everyone got it or not. Everyone do let me know. Till now everyone, is it clear? Then I will move ahead, kids. First. Let me know, do let me know, do let me know. Hit the like button if you're new, kids. Everyone, those who are being new, smash the like button. If you're new, smash the like button, kids. I want to see. Hey everyone, show me the green hearts. Till now if it is clear so that I can move ahead. I can tell you each and everything, my dear friends. Show me the green hearts. Green hearts. Saucy. Ahana. Very good. Now, all these are being strong field ligands. Now, let me tell you, in the nucleus, there is proton. In the nucleus, there is proton, and proton is like king. Proton is like king, and Raja is always attracting Ranis. Whatever the language you choose, Rani is always Rani. Electrons are like Ranis. So, these Ranis, 3d6 Ranis will remain over there, but they have to pair because the strong field ligands, electrons, the electrons which are brought by strong field ligands, they would like come near to the king. And these strong field ligands, under the influence of these strong field ligands, the electrons have to pair or they will remain individual in the individual form. Just to let me know, they have to get paired up or they will remain individually. To let me know, the electrons, these 6 electrons will get paired up or they will remain like this only. So they will get paired under the influence of strong field ligand. Under the influence of strong field ligand. Now 6 pair of electron, all they will start filling. They will start filling their electrons like this. 1 lone pair, 2 lone pair. Now another one will come in 4s, 3 lone pairs. Now p. sp3d2. While filling their electrons, the ligands occupied D2 sp3, E2sp3 octahedral. Got it? Now it has occupied inner one because it has occupied 3D, not the 4D. 4D is outer one, outside, outer one. This is inner one, kids, inner one. Now this is known as inner orbital complex. Now kids, no unpaired electron is there. So spin, they got paired, spin paired, spin paired. Now ligands have allowed them to pair up hyperligated. Hyperligands are acting as hyper forcing. Hypo means less, hyper means excess. Hyperligated. Everyone got it. Everyone got it. E2sp3 octahedral complex. Octahedral. This one everyone got it, kids. Now the same, no unpaired electron is there. No unpaired means diamagnetic in nature. We will say it is diamagnetic. Diamagnetic in nature because no unpaired electron. Bohr magneton will be 0. Bohr magneton will be 0. And in place of this, if somebody has given, but first of all, everyone understood, then only I'm going to give you another one. If everyone understood, show me the green hearts. Show me the green hearts. If everyone understood, kids, then only Baba is going to deal with another one. Keep on showing green hearts, kids. Now, by chance, if they have given you compound like this, if they have given you compound like this, COF6, now you can easily say, kids, this is weak field ligand. Now, once this is weak field ligand, kids, what will happen? Do let me know what is going to happen. You know that cobalt atomic number. Science teacher very crazy, man. Felt cold. 27. 27, just reverse it. You know the drill. 72. 3d7, 4s2. Now cobalt 3 plus. Cobalt 3 plus. So eliminate out 3 electrons. 2 from here, 1 from here. 3d6, 4s0. Now this is weak field ligand. Won't be able to pair. Won't be able to pair. Now what is going to happen? This is D. This is S. This is P. D, and this is once again D, 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 D. Now, sir, draw it properly. What are you doing? Sorry, kid. Sorry. This is 3D, 4S, 4P, 4D. Now it is okay, Baba. Yes, sir. Yes, sir. One, run, mono. Nale, one, run, one, run, mono, nale. Now, they will not pair. This fluorine is saying, oh, Baba, what should I do? 1, 2, 3, 4, 5, 6. Oh, so it will start filling its electron from here. 1, 2, 3, 4, 5, 6, sp3d2. So which one D? This is 3D. That is 4D. Outer orbital complex. Outer orbital complex. Hypoligated. Hypoligated. Now this is spin free. The value of an unpaired electron 4 to the Bohr magneton. Bohr magneton will come out. Bohr magneton, that means paramagnetic. Unpaired means paramagnetic. Paramagnetic. The value magnitude will come out to be, Bohr magneton will come out to be under root n into n plus 2, where n is the number of unpaired electrons. So 4 into square root of 4 into 4 plus 2, that is 4 6 are 24, square root of 24 slightly less than 5. So it will come out 4.9. Am I right? Am I right, kids? Am I right? Hypoligated, spin paired, or spin free? Spin free, spin free. Got it, kids? Till now, is it clear? Show me the green hearts in the chat section if you got it. If you got it, kids, do let me know. Do let me know. Hey, everyone, do let me know. Always, whenever somebody is spamming, you keep on showing your green hearts, red hearts, then the spammer will go away, because spammer can do spamming only when you are not showing green hearts. If number of green hearts coming from your side, his spamming chat will get disappeared. His spamming chats will get disappeared. Whenever some spammer is there, you can always start putting green hearts, red hearts, whatever the symbol you are getting, always keep on putting that. He or she will go away. Now, my dear students, remember that. Let me tell you one thing. Just see, science teacher, how to find out Bohr magneton speedily. See, Bohr magneton calculation speedily. Suppose if I say candium 3 plus, titanium 3 plus, rest of 2 plus, titanium 2 plus, science teacher, very crazy man. Felt cold in night with cousin. Just find out number of unpaired electrons. Everyone just find out number of unpaired electrons in all these. The value of n. Let me write down. Am I right or wrong? I don't know. I will be right or no, wrong? I don't know. I'm writing here 0, 1, 2, 3, 4, 5, 4, 3, 2, 1, 0. Just check it out. Am I right or wrong? I have written randomly. I have written on my basis of memory. Just check it out. Am I right or wrong? Whatever I have written is right or wrong. Kids, do let me know. I have written randomly. Just check it out. Whether am I right or wrong, kids? Oh my God, Vasu, so speedily, very active. Thank you, Vasu. Thank you. Thank you, Vasu. Thank you. Okay. Now, Baba is going to tell you one thing. Just see. The value of Bohr magneton, how will you write Bohr magneton? Bohr magneton value, see, magnetic moment. It can never be less than 0.1. See, 1.73, 2.84, 3.87, 4.9, 4.5.5.92. Can you see something, kids? Can you see something? That if this is 1, then 1 point something, 2 point something, 3 point something, 4 point something, 5 point, then 4.9, 3.87, 2.84, 1.73. Got it? Now there is break, kids. After break we will meet. Okay. So let me give you break off. Break off. What time, kids? Short break. Short break, kids. Short break. Short break. Right now it is 12:30, 1 p.m. 1 p.m. Let's meet at 1 p.m. Let's meet at 1 p.m. Right, kids? Everyone, call your friends, your classmates, schoolmates. I will tell you the shortcomings of valence bond theory, each and everything. We will continue with the color. After this, I will tell you the color also. Okay, kids? Okay. Everyone, you have to come with the positive energy. Come with the positive energy. Welcome back again, all my dear students. Just to let me know, can you hear me? Can you see me? Everyone, do let me know. Am I audible and visible to all of you? If yes, then show me the green signal. Oh, my dear students. Just do let me know. Can you hear me? Can you see me? That's really fantastic. And meanwhile, I've done something for you kids. I've done something for you. I will show you what I have done. Homework I have done. See, homework. I've done homework for you. See, from Tamil Nadu State Board. The missing thing in your NCERT, in our NCERT, I will show you. Let me download it. Let me download this one also. And let me download this one also, kids. These things I will show you because they are missing in NCERT. They're missing in NCERT and they holds a hell lot of weightage. So in the break, actually this break was for you kids. Baba has done homework for you. Now for this homework, the things which are missing in NCERT, and it is given in Tamil Nadu State Board. You can put some fire in the chat section that this much of hard work Baba is doing for you kids. This much of hard work, kids. Now, I was telling you about the hybridization. Now, if we are having coordination number of 4, we are having coordination number of 4. Suppose if I say coordination number 4, then two things are possible. One thing is being either the compound will be tetrahedral or that compound is going to be square planar. And if the compound is being tetrahedral, only one possibility is there, that its hybridization will be sp3. But here, two possibilities are there. It will be either sp2d or dsp2. My dear friends, Baba is always for you. Baba is always for giving you the best rank. Baba will let you know, Baba will give you each and everything which is expected to come in your examination. My dear friends, if thing is missing in NCERT and that is given in your Tamil Nadu State Board, then it becomes very, very important why Tamil Nadu students, they are getting AIR 1. Sometimes, not only because they are hardworking, you can be equally hardworking, but the thing which is missing in NCERT, that is given in Tamil Nadu State Board, and number of things are given in Tamil Nadu State Board, and I have become, and I have gone through all these things. Baba has become fan of Tamil Nadu State Board kids because of this reason. But anyways, let me tell you, let me take one example of all these things. Let me explain tetrahedral sp3, square planar sp2d and sp2. So the famous example, I will come to that example, but before that, let me take Ni finite whole 4, or leave it. Let me take one very, very most studied example. Most studied example, because rest of the examples are very simple examples. Very simple example. But before I move ahead, kids, one thing let me tell you, because that is very, very important, where I have told you the things about valence bond theory, the spectrochemical series, let me tell you one thing very clearly, my dear students. Over here, I've told you these are acting strong field ligands with that, and these are acting, although it was strong field ligand, but with this it is acting as weak field ligand. Here, I would like to add one point that this, you know, that if we move in the fourth period in the periodic table, fifth period in the periodic table, sixth period in the periodic table, then in the fourth period, if I talk about fourth period, then 3D, fifth period 4D, and here it's like this. So I would like to say here we are dealing with 3D series, here dealing with 4D series, dealing with 5D series, my dear friend. 3D series we know very well. Science teacher, very crazy man, felt cold in night with cousin. This thing we know, felt cold in night with cousin. This we have studied, we know each and everything about this. So what actually you are trying to say, just tell us quickly. It's not something to tell you fastly. These elements, whatever the elements are there, like if I talk about, my dear students, zinc, cadmium, mercury, I will tell you in D block, copper, silver, gold. Are you getting my point? If I write like nickel, palladium, platinum, this I will teach in D block, iron, ruthenium, osmium, manganese, tectin. This I will teach in D block. Why are writing, sir? Chromium, molybdenum, tungsten, so that you, otherwise you won't be able to understand. Scandium, white terbium, lanthanum, titanium, zirconium, hafnium, vanadium, niobium, tantalum. So all these elements, if I talk about 4D and 5D, due to their anomalous behavior, number of things, lanthanoid and octanoid contraction, jet effective is too much, number of things. All type of ligands will behave as strong field ligand with them. Remember that. With these elements, with 3D and 4D, let me tell you, with the, sorry, not 3D, with the 4D and 5D series elements, series CMAs, all ligands will behave as strong field ligand. Remember that this is $1,000,000 thing. With these elements, all, whether they were weak field ligand or they were strong field ligand, they all will act as strong field ligand with this 4D and 5D. Is it clear to all of you? Is it clear, kids? Now, let me come to the point, my dear students. Let me come over here. That most studied example is Cu NH3 gold 4 2 plus. You know it, must have studied it somewhere. Where? Phalanx test. Must have studied in phalanx test, during phalanx test. That's why it is being most studied. Are you getting my point, everyone? Do let me know. Okay, now see. So if I talk about this Cu, then Cu's atomic number is how much? 29. Exceptional configuration, I will write 3D10 4s1. If I talk about Cu2 plus has lost 2 electrons, so 3D9 4s1. What do you think? Oh, sorry, 4s0. 3D9, if I say 3D9, my dear friends, 3D9 will be like this. If I talk about 1, 2, 3, 4, 5, now it's here S, it's here P, it's here D. Can you get it, kids? Here D. Now, my dear friends, 3D9. If I try to fill 3D9, 2, 4, 6, 8, 9. There is no space whether strong field ligand or weak field ligand. It is although being strong field ligand, but can it shift it over there? No, it's not possible. And from where it has to start filling its electron, it is expected. I'm writing this is expected. Expectations that a student will do, they will start filling from here. And if you start, this is P, this is P1, let me divide it like here. What do you think? Expected hybridization is what? Expected hybridization is sp3. sp3 is the expected hybridization. sp3 is the expected hybridization, right? But this is wrong. This is found to be wrong. Absolutely wrong, my dear. This is found to be absolutely wrong. Why? Experimentally, it was found to be square planar. This compound was not found to be tetrahedral. Its structure was found to be square planar. Experimentally, structure was found to be square planar. So now, square planar complex means what? Its hybridization will be either DsP2 or sp2. From there, they have started thinking that hybridization is mathematical manipulation. They started thinking that hybridization is mathematical manipulation. And now they said, let's see what has happened. So they started thinking what should be the hybridization of this Cu NH3 whole 4 2 plus. Then they thought what? Just see. This is 1, 2, 3, 4, S, B, and D. 4D. 1, 2, 3, 4. Now see, it's 9 electrons. Out of 9 electrons, 1, 2, 3, 4, 5, 6, 7, 8 have thrown out 1 electron, and its ammonia's electrons, they have started filling like this. And D, S, and 4 lone pairs, P2. They said its hybridization will be DsP2. DsP2, because the shape was found to be what? The shape was found to be square planar. So it is given in the books that this is a hybridization of this compound and its shape is square planar. Agreed, kids? Square planar. So if in the examination it is coming, you have to write down this is the hybridization. This is the hybridization. Is it clear? Show me the green hearts if it is clear to all of you. If it is being clear to each and everyone, show me the green hearts, kids. Fast, fast, fast. Everyone, show me the green hearts. Now, there is twist in the story. There is twist in the story. There was one scientist. Scientist named Halogens et al. Halogens et al. Halogens was the name of scientist. Et al. means co-workers. Halogens, see what a name. Halogens. They raised one question that the one electron has gone far away, and one gone far away from the nucleus. There must be nucleus having positive charge, and it must be applying force of attraction on these electrons. So that electron has gone too far away. That force of attraction will be very, very less. Force of attraction but decreased too much. And once the force of attraction has got decreased, that means this electron can easily be eliminated out. That means Cu2 plus would have undergone oxidation to form Cu3 plus. Cu2 plus would have undergone oxidation to form Cu3 plus, kids. Are you getting my point? But this doesn't happen. This doesn't happen. That means this can never take place. This is not possible. That means this electron's probability to find over here also very tough. So, my dear students, although this hybridization is correct, but another hybridization, if in place of this, if another hybridization is given, that will be against Attell's hybridization, then that will also be correct. Let me tell you what's that. Let me tell you. According to Huggins-Attell, if they are asking, according to Huggins-Attell, according to Huggins-Attell, what should be the hybridization? Just see. 9 electrons I have told you. 9 electrons will be like this. 1, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. It will remain over here according to Huggins-Attell. So S, P. So he said that my 4, that means ammonia's 4 electron lone pair will start filling from here at 2 electron, 2, 2, at sp2, and 1 orbital they will occupy from A. No problem, because this is also correct. This is also correct. So sp2d, and the hybridization will come out to be sp2d. This will also be square planar, so there is no problem in this hybridization, and this electron will remain nearest to the nucleus, so no need to undergo oxidation. So for this compound, there are 2 hybridization, and both are exactly correct. Either they are giving you dsp2, that is also correct, or they are giving you sp2d, and this is also correct. Both are equal. You got it? This is really very important one. You got it? Show me the green hearts. Then I will move towards, first I will tell you what are the shortcomings of valence bond theory, and then I will let you know the color theory. Kids, show me the green hearts if it is being clear. If it is clear to each and everyone, do let me know so that I can understand. Now, shortcomings of valence bond theory. Limitations or shortcomings of VBT, valence bond theory. Now, my dear friends, number of times you must have gone through shortcomings of valence bond theory, but you won't be able to remember it in your brain. Yes, so how to learn it? Now see, the trick I have made VBT. Now, not only I have made this trick, but this trick is made by students also. So, you know, W, B, T. W, if I create like this, W, you know, W, V, valence bond theory, and W is for Wasim, and B for Baba. Wasim Baba's theories, shortcomings. Wasim Baba's theories. Now see, what is this trick? Trick is color of Maggi masala. Let me write down first of all the trick. Trick is color of Maggi masala. Color of Maggi masala color of Maggi masala along with tomato ketchup, along with tomato ketchup, inside and outside is different. Inside, outside, different. Now, what is the meaning of this? Just see. Valence bond theory cannot explain color, unable to explain color. Color is not explained. Color is not explained. Maggi masala means magnetic movement is not explained. Magnetic moment is not explained. Tomato ketchup, see, TCP, thermodynamically controlled and kinetically controlled product. What is their stability? Thermodynamically stability, kinetic stability. Tomato ketchup, tomato ketchup. See, tomato ketchup. And outside, whether the orbital is inner orbital complex or outer orbital complex, outer orbital, inner orbital, that is also not explained. Not explained. See the trick. It is working or not? If yes, Baba want to see the green hearts. Gets this trick. Baba and Wasim's theory does not explain about color of Maggi masala along with tomato ketchup, inside outside difference. Kids, if you are really liking it, I want to see in the chat section the green hearts. If you really liked it, wow, I can see the green hearts. Really awesome, really awesome. Now, let me move towards color theory. Now, today, I will let you know how to find out color of any compound, color of any complex compound, No need to cram it. Cramming is not required, kids. Baba will tell you simply with 3 points. Just try to understand these 3 points. What are these 3 points? See, one is, you know very well, electrochemical series. Okay, electrochemical series, you know very well. Second thing, oxidation state of central metal atom. And third thing is color wheel. Color wheel. These 3 things, if you can keep in your brain, then you can find out answer of any complex compound. You can find out color of any complex compound. Now let me tell you. If the ligand is a strong field ligand, remember that. Strong field ligand with higher oxidation state. If these 2 combinations are there, strong field ligand with higher oxidation state, then the color absorbed will be color absorbed will be of high energy, will be of high energy, very high energy. Remember that. color absorbed will be of very high energy, and the emitted color means we will see with our eyes. Our eyes can only see emitted color, that is observed color. Emitted, that means we can see with our eye, E for eye, E for emitted, or we can say observed color. Observed, absorbed, in absorbed there is B, sorry, absorbed there is B, absorbed, and the observed color we can say of low energy or least energy, Let me make one point very clear. So that you should not get confused. What I'm saying, if you are provided with higher or highest oxidation state plus strong field ligand, then the absorbed color will be what I'm saying, absorbed color will be of highest energy, once again I'm telling you, highest energy, and its complementary color will be of least energy. The complementary color, which is complementary color, kids? Complementary color, that is, we can say emitted color, or we can call it observed color, which we can see with our eyes. Observed color, that means the eyes which we will see, which color the eyes will see, kids. Eyes will see only this color, that will be of least energy, or I can say maximum wavelength, maximum wavelength, kids. Maximum wavelength, and this is least wavelength, right? And opposite to that, if I say less oxidation state, weak field ligand, then they will absorb light of least energy, and they will emit out light of highest energy. Is it clear? Is this much clear? Now let me draw the color wheel. Let me draw. Are you ready? Show me fire in the chat section. Kids, you are far away from me. Only your chats can give me energy, or chats can show me that you are ready, you are getting it, because your understanding is more important than anything else. Understanding is more important. So now I'm going to draw color wheel. This is only for you. Nowhere, no other channel till now in the world has shown it. No one else. Now after this, if anyone is going to show you, if anyone is going to teach you, that is another thing. Baba is the first one who is going to make it clear with the logics. No need to cram it. Cramming is not required, kids. Okay, now see, color wheel. This is color wheel. Now let me divide it. I have divided in two parts. Just see, I have divided in two. If I say left hand part, right hand part. This is being left hand part, left hand side. That is being right hand side. If I say left hand side is of maximum energy, light of maximum energy, And at that side, if I say light of maximum wavelength, okay, light of maximum wavelength, I can say light of maximum wavelength, light of maximum wavelength. Am I right? If I say least wavelength, and if I say here least energy, am I right? Now, what thing you will get in your brain with the help of this? I can divide it into two more parts like this. Just see one part, another part. Can you see, kids? Now I will write VibGure. Just see, I am going to write VibGure. VibGure. Violet, indigo, blue, green, yellow, orange, red. Can you keep this thing in your brain? Or if I write VIP, VIP, violet, indigo, purple, blue, green, yellow, orange, red. So, what is the complementary color? What is the complementary color of green? Complementary color of green is red. Complementary color of blue is orange. Complementary color of VIP is yellow. Or I can say the complementary color of orange is blue. Complementary color of red is green. The complementary color of yellow is violet, indigo, purple. Can you understand, kids? Can you understand? This is rough diagram of color wheel. I will go more into the depth of this color wheel. Color wheel diagram. This is very, very basic diagram. Very, very basic diagram. I will give you more advanced level of this, but before that, you know, the paper of bio is of how many marks? 360 marks. 360 marks. So this is 360 nanometer wavelength. Wavelength is 360 and the whole paper of NEET is of 720 nanometer. Red color's wavelength is maximum. This is maximum wavelength or least wavelength. Least wavelength, maximum energy, maximum energy. This is maximum wavelength, least energy. Right, kids? Till now, is it clear to all of you? Now, I will draw a bit better diagram than this. Just see, so that only you can understand. If I write down like this, and if I say that this is red color, this is, I'm going to draw red color like this. If I say the red color is like this much area is of red. This is of red color area. In the color wheel, if I say this is red, and red is a bit merged with orange. And if I say this is orange, and this orange is bit merged with yellow, this is only the color wheel, kids. If I say this is being purple, just try to understand. If I say this is being purple, kids, if I say this is being purple, oh my god, this is being, you can understand what I am telling you, kids. Dang, not working. Just wait for some time, few minutes. Not working right now, kids. Just give me a few seconds and see. Oh, not working. We have to wait for a few seconds. Let's see your chat section. It got confused. Kids, it got confused. Show me the green signal in the chat section. Hey God, let it start working. Just pray. Pen got tired. The board got tired. Show me some green hearts so that Baba should not get tired, kids. Baba should tell you each and everything, kids. Show me the green hearts so that Baba should not get tired. Hey, just, yeah. It started working. So if I say, here is blue color, kids, blue color. Now I will not make anything fast. I will do everything slowly. Blue, green. Can you see, kids? Can you see? They are merged. Our rainbow is continuous spectrum. Can you see? Our rainbow is continuous spectrum. And what thing you can draw from this thing, that red is coming from this area. This is, what is it? Just see, they are bit making this red color. Just see red color. It's like this. So I would like to say blue green are the complementary color of red, or simply green is also the complementary color of red. How to learn it? Green tomato or green chilies, one day they will become red chilies. Tomato green, one day will turn out to be tomato red. It will become red. So you can remember beggar. So this is the trick to remember. Beggar means blue green will turn out to be red. Blue green will turn out to be red. Are you getting my point? Now, let me show you, kids. Let me show you the Tamil Nadu State Board. Tamil Nadu State Board color theory. Yeah, got it. Thank you, Tamil Nadu State Board. Just see, kids. Can you see, kids? Is it visible to all of you? Just to let me know. Do let me know, kids. Is it visible to all of you? Now see, blue-green. First of all, see Vibgyor. Is it visible? Is it visible to all of you, kids? First of all, do let me know, is it visible to all of you? Say yes, it is visible to each and every one, kids. Do let me know. That violet, indigo, blue, green, yellow, orange, red. Continuous spectrum. Continuous spectrum. This is shown in Tamil Nadu State Board. Very fantastic. Now see, if I say this blue-green, this whole area is looking like red. Red. See, red area is maximum. Yellow is least. Yellow is only little bit. Green and blue is maximum constituting red. Blue-green is red. Violet indigo is yellow. This is being violet. Violet indigo. Only bit yellow is here. Can you see, kids? Kids, show me the green hearts if you are really liking it. The Tamil Nadu State Board diagram. How much efforts I have done, kids. You can't show me the green hearts also. Then only you can understand, kids. Then only you are going to understand. It's what happened. Yes, Madhubala, welcome. Rose, Babita, Abhinay. Very good. Now, let me tell you the color. You keep your NCRT with yourself. Now I am going to explain the color of each and every complex compound. I am going to explain color of each and every compound. Just see. In your NCERT, these compounds are given. Just see. CO, 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 cyanide, whole 6, 3 negative, CO, ammonia, whole 6, 3 positive, CO, ammonia, water, 3 plus, and CO, ammonia, whole 5, chlorine, and 2 plus. These 4 compounds, just see, they are given in NCERT or not? Do let me know. A, B, C, D. Now, how to find out color of these compounds? Just see. Cobalt is having oxidation state. Cobalt's oxidation state is how much? 3 plus. Cobalt is in 3 plus oxidation state, and this is a strong field ligand, very strong field ligand, very strong field ligand. So write down in the chat section. High energy color, highest energy color it will absorb, or least energy color? Just do let me know in the chat section. High energy color or least energy color it will absorb? Do let me know if you are able to understand, kids. Let me check it out whether you are going to become doctor or not. The channel is writing you want me as a friend or not. Oh my god, what's going on? It is the place to play doctor or to play brother sister? My god, kids, you do one thing. All today's students always show green signal as a heart so that their spams, their comments should not be, they shouldn't be able to see their messages. Any is writing least energy, high energy. Oh my god, it's, see what I have told you. If highest oxidation state, B plus is highest oxidation state, strong field ligand, then the absorbed color will be of highest energy. That means it will absorb violet color. It will absorb VIP color, VIP, violet, indigo, purple, or even I would like to say CGX UV, ultraviolet rays. Somewhat it will absorb better than that UV rays. So what is a complementary color? Complementary color, that means it will look like to our eyes will see which color. Emitted color will be yellow or light yellow, or light yellow, yellow, dirty fellow. Just check out your NCERT. This color is given over there or not? Check in your NCERT. Everyone, you have to check it out. Baba is telling you $1 million thing, and I want to see in the chat section. That you got it or not, kids. Baba is giving you so much quality content, you will not get anywhere, kids. Call everyone. Who study from Baba. And kids, just a second. Now kids, just see, now this ammonia is bit weaker. It is strong. This was very strong field ligand, but this is very strong. That was very double very. This is very strong field ligand, but less than that. Less than that. Now cobalt is in +3 oxidation state. Cobalt is in +3 oxidation state. Now it will absorb light of higher energy, but less than that. Let me show you the color wheel. Let me show you the color wheel. Means which color light it will absorb. Which color light it will absorb. Just see. If I say, let me divide it into these many parts. These many parts. So this was VIP. This was blue. This was green. This was yellow. This is orange. This is red. That one has absorbed blue light. Now this one will absorb which color light? This will absorb blue color light, and blue color light will convert it into complementary color orange. So this compound should look like either orange. I would like to say, you will say, sir, how to find out only orange? Or you can say it will absorb somewhere here, either here or there, or it can be like this, either orange or light yellowish orange. Either orange. So it will look like which color it will emit out, because it has absorbed blue light. Absorbed light is being blue, so definitely it will look like yellowish orange. Yellowish orange, or I can say it will look like orange color if it is given over there, kids. This is the color emitted color. If it is given like this, show me the green hearts and let me know, yes sir, it is given like this only. It is given like this only. And this is ammonia and 1H2O with cobalt. H2O is strong field ligand. This is strong field ligand. So it will become strong field ligand, and it will absorb a bit less than that. Bit less than that means blue-green light, and blue-green will look like red. Blue-green look like red. So it will absorb blue-green light. Blue-green light. It will be emitting red color light. Red color light. And see, this is weak field ligand. Weak field ligand, but cobalt is, sorry, it is, yeah, it is -1. So cobalt will come out to be +3 oxidation state. This is saying I will absorb light in high energy, and this is saying I will absorb in less energy. So boundary line of high and low, this is the boundary line. So it will emit out a bit of violet color light. It will absorb yellow here, and it will look like violet. So will absorb yellow light and will look like violet or purple. Now kids, do let me know, all these 4 compounds are showing this color only or something else. Show me, let me know in the chat section, they are of this color only or not. Do let me know. If yes, show me the green hearts, kids. If it is given in NCERT, check it out in NCERT. If it is given like this, kids, do let me know. Hey everyone, I want to see in the chat section your response. Show me the green signal if it is given like this only in the, everyone do let me know. I want to see, kids. Your reflection means a lot. Always as the strong field ligand. Page number 259. Very good. Ipshita, very good. That's really fantastic. Ipshita is fantastic. student Ipshita is going to score very high. It's 259 page number. It's given like this only. Okay, I will repeat it, Akshay. I will repeat it. But first of all, everyone do let me know you are able to understand or not. Yes. Now see. Let me give you in the form of question. Let me give you in the form of question. Suppose you have to remember this thing. Suppose if they have given compound like this, the question like this, see the question. What type of question they can give you? Just see. Just see. What color will be emitted by Now let me give you number of questions based on this. First, let me give you compound like this. CuCO cyanide whole 6 3 negative. Now options are A violet, B blue, C green, D yellow. Now how to answer it, kids? How to answer it? Just see. How can you answer this question? Just find out this cobalt's oxidation state is how much? X plus 6 into minus 1 is equal to minus 3. So X will come out equal to plus 3, right? Cobalt is in highest oxidation state, right? Now, cyanide is very, very strong field ligand, right? These two things are indicating what color it will absorb. Will absorb very, very high energy light. Am I right, kids? Very, very high energy light. So it will emit out complementary color of very, very high energy light. Very, very high energy light is VIP, violet, indigo, purple. What is the complementary color of violet, indigo, purple? Just see which color is opposite to violet, indigo, purple. It's being yellow. And if it is absorbing this light, suppose if I say I don't know whether it is going to absorb this light or this light or this light, no worries. Its color, appearing color will lie in this right hand area, and the right hand area color is which one? Do let me know which color is in the right hand area. Just do let me know what's your answer. It's do let me know in the chat section what will be the color. Everyone do let me know. Yellow. That's really fantastic. This is really fantastic. Yellow will be the answer. Okay, kids, are you getting my point? Everyone? It's just a second, just a second. Now, whatever I told you over here, that these questions you can do very clearly. Now, should I give you those questions which you have not seen? Are you ready? I will give you questions from the NCERT only. But these already I have explained. Should I give you question which you have never seen? and you have never crammed it out, but you can answer it. Should I give you? Should I give you? See. Question is color emitted by Ni, water, whole 6, 2 plus. Just focus on the concept. No need to cram it out. I'm giving you options. First option, red. Second option, orange. Third option, reddish orange. Fourth option, green. Now apply your brain, kids. Just think of that this is your NEET examination and apply your full brain. Let's see that question can be done by you or not. My dear students, do let me know. Red, Dinan, congratulations. Wow. Dinan, wow, wow, kids, really awesome. Green, oh, red or green? Dinan, I think red or green. Even I am sorry, Dinan, it's not red. I think red is a wrong answer. The answer is red is absorbed. See, answer will be green. Dinan, absorbed. See, nickel is in which oxidation state? Nickel is in +2 oxidation state, lower oxidation state. Water is weak field ligand. So the absorbed color light will be least oxidation state, weak field ligand. So color absorbed will be of least energetic color. Least energetic color will be absorbed. Least energetic color will be absorbed. So least energetic color, who is least energetic color? Definitely red color will be absorbed. Red will be absorbed. So what is the complementary color of red? The complementary color of red is what? Complementary color is being green. So green is the answer. You got it? How many of you got it? How many of you got it for the first time that you can do the colors even without understanding what? And without cramming it? You can do it with the logics. Do let me know. Let me give you another question. Let me give you another question. Just see. If I give you compound like this, nickel H2O whole 4 En 2 plus. Now options, color of this compound. Color of this compound. A, violet. B, red. C, orange. D, bluish green. Bluish green. Do let me know. Let me check it out. This is the last question based on color, kids. Last question based on color. Let me check it out. What's your answer? Let me see, kids, in the chat section, whether you are able to do it or not. C, orange. Bhavani Prasad is going for C. Let me see who is going to get correct answer. Abdul Sean is going for D, red. D. So finally, what should be your answer? Let me check it out, kids. D. I'm very happy with the performance of those students, those who have gone for D. D is being the correct answer. Why? This is being a strong field ligand. This is being weak field ligand. Weak field ligands 4, that is 2. Nickel is 2 plus. So nickel is in low oxidation state and weak field ligand 1 is strong field. So red it will not absorb. It will not absorb red. Red, no, it will not absorb red. So it will absorb what? Either it will absorb orange or it will absorb in between red orange. So definitely the color will be bluish green because orange is absorbed. Red or orange, they can be absorbed. Violet, no possibility. So definitely it has to look like bluish green. How many of you got it till now? Those who got it, those who are able to understand, show me green hearts, otherwise fire. Let me check it out. 50%, even 50% students are able to understand this color theory or not. If yes, then I will feel happy that 50% students are able to understand. At least 50% students, that means a lot to me, kids. 50%, even 50% only, that means a lot to me, kids. Wow, I can see green hearts. That's really awesome. Fantastic. 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 Okay. Wow. Now, my dear students, after this, there are two things. One is being isomerism, another one is splitting. Splitting, crystal field theory. So, what you want to study? First, crystal field theory, or you would like to study isomerism? I for isomerism, CFT, crystal field theory, CFT. Let's see, first you want to study crystal field theory or isomerism, kids. Let me check it out. CFT, wow. Vote for CFT are more. CFT votes are more. So let me start with CFT. Let's see, kids. But before starting CFT, let's do questions. Let's do questions. Whatever we have studied, how many of you want to deal with the questions? Color theory questions. All the questions are rank deciding. All, first let me tell you, all questions are rank deciding questions. Those who don't want to get rank, they can leave these questions. Rank deciding. All questions are rank deciding. Which of the following complex ions is expected to absorb visible light? To have visible light, the value of N should be greater than 0, or means you can write 1 or more than 1 unpaired electron. N is number of unpaired electrons. Number of unpaired electrons. See, till now I was giving you questions from my side. This question is from, you can say already they can ask question like this. So how many of you are going to give me the answer? I want to see in the chat section. Do let me know what's your answer. Everyone, do let me know in the chat section. I want to see in the chat section. Take your copy and pen and think it to be Abdul Sean is going for A. B. Rutika is going for B. A, B. It's going like A, B, A, B. D. Somebody, Shashank is going for D. Oh my God. So let's see how to do it. Time is more than sufficient. Let's see. It's the answer is B. Now, how to find out that B is going to be the correct answer? See to it. Let me explain how to find it out. Now, see, titanium. If I talk about titanium, titanium's atomic number is 21. 21. And see, this is 0 oxidation state, 0. Sorry, 0 is neutral ligand, 4 plus. 4 plus, my dear friends, 4 plus, titanium is 4 plus. So that means already it is having 21. So I can write 3d1 and 4s2. It has lost all the electrons, my dear friends. So what it will look like? No unpaired electron is equal to 0. No unpaired electron. Zinc. If you remember, zinc was at the last. Zinc's atomic number was 30. 30. So I will write 3d 10 4s2 and it has lost 2 electrons. So Zn2 plus will be 3d10 4s0. It is also having the value of n to be 0. No unpaired electron. Now scandium 3 plus, I have told you whether 3 plus, oh sorry, scandium, titanium or scandium. This is wrong. This is wrong, kids. I've written 21. This is 22. This is 22 titanium, because science teacher very crazy man. Science teacher very crazy man. Science teacher. This is 21. This is 22. If it is losing 3 electrons, scandium 3 plus n value is 0 and titanium 4 plus value of n will come out to be 0. That means they are not having any unpaired electron. Now, if I talk about chromium, chromium's atomic number was 24. Exceptional configuration 3d5, 4s1, and it is in 3 plus. So if it is losing 3 electrons, 1 from here, 2 from here, so 3d3 unpaired electron. Can you get, are you able to understand? Did you understood? Did you understood? Did you understand, kids? Have you understood, kids? Do let me know. Have you understood? Did you understand? Everyone, if this is clear to all of you, do let me know in the chat section. Yes, sir, we got it. Yes, sir, we got it. Have you understood, kids? Do let me know. Have you understood? Everyone, do let me know. Show me the green hearts if you got it. Very good, very good. Now see, I have given explanation, already written explanation is there. Now another question on your screen. Do let me know. Let's see this question's answer. Will you be able to give the correct answer or not? Let me see, kids. Do write down in the chat section what is the answer of this question. Let me check it out, kids. Everyone. Fast, fast, kids, fast. Answer of this question. Let me check it out in the chat section. How many of you are able to give the correct answer of this question? My dear friends. Everyone. Fast, kids, fast. Everyone fast. Answer, I want to see the answer, kids. A. By Reddy is going for A, Nazima A, A. Most of the students are going for A. Now let me check it out whether A is being the correct answer or not. A is the correct answer. Now my dear students, how many of you thinking like that? Sir, we are able to do this question, but it requires lot of time. It is requiring lot of time. Is there any way to do it more speedily? Yes. How many of you want to do it more speedily? Now see, if I tell you the way, the trick or the logic, science teacher, very crazy man, felt cold in night with cuisine. Just see, if I say this is the train, if I say this is being the train. Now, if by chance, or should not do that, by chance train is going to have an accident, who will be affected most? Who will be affected most? The people, those who are here, and the people, those who are over here, right? So my dear students, remember that if this is going to lose 3 electrons, it will have n value 0. If this is going to lose 4 electrons, then the value of n will come out to be 0. Now, if this is going to lose 2 electrons, its n value will come out to be 0. Am I right? Am I right? Now, if I talk about this cobalt, and if this cobalt is with strong field ligands, and in cobalt 3 plus, then it will have value of n to be 0. This is the way, this is the trick, Baba HSP's trick, and the logic, you can say, not only the trick, this is the logic. Now let's see, let's understand. Definitely you will get answer immediately. Just see, which of the following ion is not expected to absorb visible light? Nickel is over here, iron is over there, chromium is over there. Now nickel is coming 2 times. Now this nickel is with weak field ligand, and weak field ligand cannot pair the electrons, can't do pairing of electrons. Are you getting my point? Can't do pairing of electrons, can't do pairing of electron, and this here electrons will get paired, Now simply you can see, out of these 2 nickels, which should be the answer, the one who is being paired. Just see the explanation also. Nickel, number of unpaired electrons 0, here number of unpaired electrons 2. So you can see all this is being weak field ligand. With chromium, this is being weak field ligand. All the 3 are being weak field ligands. They cannot do the pairing. Only this is being a strong field ligand, can do pairing, and due to pairing, unpaired electrons will not be there. Now see another question. So the following compound is not colored. Let me check it out. Now see which answer you are going to give. Let me see, kids, in the chat section. Let me check it out in the chat section, what answer you are going to give. I'm waiting for your answer, kids. Fast, kids, fast. Do let me know. Fast. I want to see answer. Yes, kids, yes. Everyone. B. Ruthika is going for B. Most of the students, they are going for B. Let me check it out. B is the correct answer or not, kids? Wow, congratulations. Now cadmium. With cadmium, every ligand will act as, now see how to do it. Zn, zinc, cadmium, mercury, they all belongs to the same position, that if they are in 2 plus, they will have n value equal to 0. Zinc, Canada with mercury, then CD, mercury or zinc having Canadian hugs. You can learn it like this. Zinc is having Canadian hugs. Canadian hugs. Zinc is having Canadian hugs. Now see kids. Now I hope that everyone is able to understand this. I have shown you. Now another question. Wavelength of red light. Wow, awesome question. Wavelength of red light is absorbed by. Now this is really one of the awesome, fantastic question. Fantastic, really fantastic, fantabulous question. It's, I would like to say fantabulous. Fantabulous. Let's see who is going to give the correct answer. That will be the genius one. That I will say yes, you are HSPN, then I will say you are HSPN. Red light will be absorbed by whom? Let me check it out. Yes, yes, yes. Let me check it out. Who is going to give the correct answer, kids? A, B. Somebody is going for A, somebody is going for B. My dear students, remember that. Remember that. This is the correct answer. Now you know. CuNH3 whole for 2 plus. This compound, you remember that this is going to absorb red light. Why it is going to absorb red light, kids? Why? Because you know that the color of this compound is what? Yes? Do let me know. Then you can answer it very clearly. Now see kids. When ammonium hydroxide is added to the solution containing Cu2 plus ion, deep blue solution. So its color is deep blue solution. If I say, if I am provided with CuOH whole twice, then it is precipitate. This is light blue PPT. This you have studied in salt analysis, if you have studied, and that is deep blue solution. And deep blue solution means blue is going to absorb orange, and deep blue, definitely deep blue is something over there that is going to be absorbing that color. So now the wavelength of light absorbed is highest in. Wow, fantastic question. Once again, fantastic. Show me the answer in the chat section. Let me check it out. How many of you can do this question? Fast, fast. The wavelength of light absorbed is highest. It's, if you're new to this channel, just joined it, hit the like button. I want to see 550 likes. Fast, kids, fast. Answer it fast. Make it fast. Let me check it out. How many of you can give it? This is really very question, good question. B. Most of the people are going for B. Let me check it out. Light absorbed highest wavelength of highest. That means least energetic. Least energetic light absorbed. Least energetic light absorbed. Least energetic light absorbed. Right? Least energetic light. Now see cobalt 3 plus cobalt 3 plus cobalt 3 plus cobalt. In all of them, cobalt is in +3 oxidation state. So this En is strong field ligand, strong field ligand. This is a strong field ligand, strong field ligand. This is being strong field ligand, strong field ligand. But chloride is weak field ligand, so it will absorb least energetic light. So what's your answer? What I can see, what's your answer? I will go for A. For what you have gone? For what you have gone? A. It's working. It's working, kids. If it is working, show me green hearts. Baba has told you each and everything in such a great way that you can answer any question. And this, see, chloride is present. Chloride is present as a ligand which is weak amongst the ligands. Now, this is the answer. Now, oh, wow, what a great question. What a great question. Really a great question. I would like to say great question. Great question. Let's see how many of you can really answer it. Really awesome question. Fantastic question. Let me check it out. How many of you can answer this question? Really fantabulous question. So, kids are going for B. Let me check it out. Even I will check myself whether I am able to do this question or not. See, the correct order for the wavelength. Increasing wavelength means decreasing energy. Decreasing energy means the one who is having maximum energy should be lie on the left hand side. That means left hand side will be maximum oxidation state, highest oxidation state, and strong field ligand. Now let me check it out. What is this? What I have written? Left hand side will be highest oxidation state and strong field ligand, right? Strong field ligand. Let me check it out. Nickel, nitrite, strong field ligand. They are not that much, they are weak field ligand. So answer will be from here only. Now nitrite is there, ammonia, water is weak field ligand, and water should be at the last. I will go for A. This is strongest field ligand, and this is strong field ligand, and that is weak field ligand. And weak field ligand will absorb energy of maximum wavelength. The correct order for wavelength of absorption in the visible region, the correct order. So I will go for A. Let me check it out. You people have gone for which option? You people have gone for which option? So A is the correct answer. Yay! Even Baba has done this question. Baba has done this question, kids. Really awesome. Really awesome. Really awesome. The explanation, see, this is a spectrochemical series given over there. There is nitrate, remember, and here is being nitrite. When remember that when ammi is there, educated ammi is there, so night will go right only. Night is right. That's why I can go with this. Okay. Okay, this you can remember, it is from qualitative analysis. I will let you know after this. So the explanation given over there. Which one of the following is an outer orbital? This is from hybridization. Try to get the answer. This is from hybridization. Let me check it out whether you are able to do it or not. Fast gets fast. As the like button, make it 550 kids. Wow, 551 already. Really awesome. That's really awesome. Let me check it out. Who is going to give the correct answer, kids? Whose answer is going to be correct? Fast, fast, kids. Fast. Very fast. Kids, everyone. Fast, kids, fast. B. Most of the people are going for B. Some are going for A also, kids. B, B, A. Okay, just see. Which one of the following is an outer orbital complex? Now check it, kids. Check it out in my way. This is strong field ligand. This is strong field ligand. Can't be outer orbital. So fourth can't be the answer. C. First, nickel with ammonia. Ammonia with nickel is weak field ligand. So you can say this is the correct answer. And already I have told you. So, oh, what is this? Pairing. For this, I have to explain crystal field stabilization theory, then only we can do these questions. So are you ready for CFT? Are you ready for CFT, kids? For this, I have to explain CFT, then only we can do this question. Is everyone ready for CFT? CFT, crystal field theory, CFT. Just to understand this theory, kids, we have to understand CFT in octahedral complex. Octahedral complex. That is, octahedral complex means coordination number 6. Now, to understand this, we should know one thing clearly, that if we are provided with D subshell 1, 2, 3, 4, 5, out of these 5 kits, 5 orbitals, if I put designation dxy, dyz, dzx, and these two, I would like to say dx square minus y square and dz square. Am I right? They all are having same energy. All have same energy, right, kids? Right now, they are like 5 brothers. 5 brothers having different approach but same energy. You can call them to be Pandavas or anyone having different approach but same energy. Why different? These 3 are different and these 2 are different. If I draw these 3, then I would like to say that they lie in between axes. If I say this is x-axis, this is y-axis, and dxy will lie in between axes. Dxy, yz, zx, their orbitals are in between the axes. These 3, their orbitals are in between the axes. Orbitals are in between axes, kids. Now, if I draw dx square y square, then how it will look like? Dx square y square will look like this. See, kids, x-axis and y-axis. This is being x-axis, this is being y-axis. Then their lobes will lie on the axis. Its lobes will lie on the axis. Dx square and dy square, the lobes are exactly lying on the axis. Are you getting my point? Lobes are on axis. Lobes are on axis. Now, if I say dz square, how it will look like? Dz square, this is suppose z axis. So, it will be like this, fused over here. This is dz square, this is also lying on the axis, So, after some time, we will call them T2 and there is to be EG. Now, that will be the story of later on. Till now, everyone understood. Till now, is it clear to each and everyone, kids? Do let me know. Now, if I say when they are going to react with ligand, now see, if I say here is being central metal atom, oh my god, this is a question. Just wait. Here I will say this is a central metal atom, and central metal atom will react with the ligand, and ligand will approach from this side, This is being octahedral complex, and octahedral complex is formed by whom? Because of the ligand. Are you getting my point? That ligands will come from this direction, ligand will come from this direction, ligands will come from this direction, and ligands will come from this direction. Ligands will come from this direction and ligands will come from this direction. This is the way from which ligands are coming along with their lone pair. These are the, this is, you can say, the road of ligand. Ligand is approaching from this direction. Can you see, kids? Ligands with their electrons, they are approaching from this direction, and this is we know as what we call it. This we call it as octahedral complex. Can you see? This we call as octahedral complex. This is only known as octahedral complex. Are you getting my point? So this is the place from where ligands, they are bringing their electrons. Right, kids? But what will happen to the, or where the electrons of this cobalt central metal atom is located? If I say their lobes, this is x-axis. If I say this is suppose x-axis, if I say this is suppose y-axis, and if I say this is being z-axis, so their 5 orbitals, where they are located, definitely just try to see their orbitals. Now I'm going to draw the orbitals of this cobalt with which pen? Let me take the blue one. I will try to draw with this blue purple one. It's the xy will lie in between x-axis and y-axis. The xy will lie like this. Dxy, are you getting my point? In between x and y, dxy will lie. Dyz, dzx will lie like that. But dx square y square, they will lie. So dx square and y square will lie over here. Dx square and y square, they are like this, x-axis and y-axis. Dx square, y square. These orbitals, dx square, y square, they are just lying on the same road as of the ligand's road. So what do you think? These electrons of dx square and y square and the ligand's electron, there will be repulsion or not? There will be huge repulsion. Due to huge repulsion, its energy will increase. Energy will get increased. And whose energy will get increased? dz square. Dz square's orbitals are exactly lying where? dz square also lying on the way of ligand, this also lying on the way of ligand. So dz square's energy will also increase, exactly same as dx square y square. dz square's energy will also increase, and if their energy is increasing, then definitely they will get energy from whom? dxy, dyz, dzx. They will get, their energy will get decrease till now. So these 2 orbitals energy will get increase, and these 3 orbitals energy will get decrease. Their energy will get increase, their energy will get decrease. There will be splitting. Let me show you whatever I have shown you. Let me show this diagram first. Let me show you this diagram given in the Tamil Nadu State Board. Just see. Let me show you the same diagram given in the Tamil Nadu State Board. This one, not this one. This one. Yes, just see. octahedral field. If you can try to visualize it, just see kids. Is it visible? Just try to understand. Dx square y square is exactly lying dx square y square on the same road, on the same path as a ligand. Dz square is also lying on the same path as of the path of ligand. Can you see kids? But they are in between the axis, but they are right on the axis. This is nice diagram given in Tamil Nadu State Board. Let me see the chat section. Is nice or not, kids? Kids, do let me know. This is really nice diagram. I want to see in the chat section or not. Everyone do let me know. This is really nice. Yes. Now, let me explain how the splitting is going to take place. How the splitting will take place, kids. Right? Really, I can see the green hearts. I can see the green hearts, kids. That's really awesome. I can see the fire in the chat section. I can see green hearts. That's really awesome, kids. Now, I would like to say that these five ligands were living happily. How can you say like that, sir? Okay, let me explain. If I say the energy is increasing like this is the energy table. Energy is increasing on moving upside. Energy is getting increased. And if I say these are the five, 1, 2, 3, 4, 5. These 5 orbitals without any separation, they were living like this. I will say dxy, dyz, dzx, dx square, y square, dz square. No splitting. Once they are going to meet with some another person, their energy will get increased. They will lift their energy. Now their energy will be like this. They will have more energy now. Just see, their energy will get increased, but still they are having unity. Still they are united. Their energy got increased, but still they are united. Unity is there. These three types kids, and those two of another type, still the unity is there, kids. Unity is there in these 5. Still the unity is maintained. They are united, but under the influence of ligand, their energy will get increased. Dx square, y square and dz square, they are known as T2G or EG. EG stands for plane of symmetry. T stands for plane of symmetry. EG, these two are EG, and these three are T2G. Now their energy will get changed, and if I say this is the barycenter, in between there is the barycenter, and 2 orbitals will have more energy. 2 orbitals will have more energy, and 3 orbitals energy will get decreased. But I'm telling you, the one whose orbitals were lying on the same path, they will get more energy, and these 3 will get less energy. Now, whose energy got decreased? 3 orbitals energy got increased. That means their energy will get increased by how much? Their energy will get increased by how much, and their energy will get decreased by how much? Then definitely their energy will get increased by 3 by 5, because out of 5 orbitals 3 got decreased, so their energy got increased by 3 by 5 and their energy will get decreased by 2 by 5. Are you getting my point? This thing, are you getting, everyone? 3 by 5 energy got increased, 2 by decreased, and that is very center. Now my dear students, stronger field ligands will give more splitting or maximum splitting. Now my dear student, there are two things. If this much is clear to all of you, we will call this to be T2G, T2G, and we will call them to be EG. Very important. Now, how the filling of electrons will take place, that holds a whole lot of weightage. But filling of electrons, should I explain? First of all, do let me know everyone is able to understand. Let me copy it. Now let me explain. If I say there is weak field ligand, suppose there is weak field ligand, under the influence of weak field ligand, and I have to fill 5 electrons, n is equal to 5. So one will come over here, one will come and occupy this space. Just see, one will come over here, second over here, third over here. Now fourth and fifth, they will get filled like this. But if I say there is strong field ligand, in case of a strong field ligand, the strong field ligand like cyanide or CO is there, and 1, 2, 3, fourth and fifth will get filled over here only, kids. N is equal to 5. Number of 5 electrons, they will get filled like this. Are you able to understand or not? Strong field ligand case, pairing will be taking place. Here, strong field ligand will cause pairing. Pairing will be done. Now, when the pairing will be done or when the pairing will not be done, this is a $1 million question. Remember that. If amount of energy required to form a pair is more. See what I'm saying? When amount of energy required to form pair is very high, then definitely very high, then definitely what will happen? Suppose if too much money is required to buy anything, suppose 1 crore rupees is required to buy anything, definitely we are not going to buy it because too much money is required. So when the amount of energy required to form pair is very high, pairing will not take place. Pairing can't take place. Pairing can't take place. Pairing can't take place. Pairing will not take place, my dear friends. So for pairing, P will be less. For pairing, P will be less. So how will you see? Here, pairing is taking place. Strong field ligand pairing is taking place. That means all these things are indicating P is less. And P is less. That means P is less than what? That octahedral energy. That means P is less than O. O means octahedral. Difference in the octahedral energy. This you can indicate. This difference is O. So here P is less. That means in this case, P is greater than. That's why pairing has not taken place. Or we can say in case of weak field ligand, P is greater than this. And in case of strong field ligands, is like that. Now, my dear friend, let me show you something very big. If I say this is 2 by 5, in place of 2 by 5, what I can write? In place of 2 by 5, can I write 5 4s are 20, 0.4? Can I write like this? And in case of 3 by 5, can and I write 0.6, this is up, so energy increase, so I can write plus. This is energy decrease, so I can write negative. Am I right? Are you getting my point? This is up. Up means energy increased, so plus sign, and here energy decreased, so negative sign. Now let me show you something very fantastic thing. Just a second, kids. Kids, now see. This is very important thing. Are you able to understand? Then only I will show you what is given, the fantastic thing which is missing in NCERT but given in Tamil Nadu State Board, and the direct question can come from there. But first of all, do let me know why it is 0.6 plus, why is minus 0.4. Everyone is able to understand. If yes, then only I will go for that. Plus 0.6, why it is plus 0.6 and why is minus 0.4. Everyone is able to understand. Then do let me know each electron contribution will be this. If I say this much is given for one electron, minus 0.4, 2 minus 0.4, that means contribution for this one electron, it will come, one electron it will come, another electron it will come, 4 3s are 12, minus 1.2, and 6 2s are 12, plus 1.2. Are you getting my point, everyone? Then only I will show you the Tamil Nadu State Board. Everyone, show me the green hearts if you are able to understand. Then Baba is going to show you Tamil Nadu State Board. Just see. Fantastic thing given in Tamil Nadu State Board, but in NCERT it is missing. Just see to it, kids. Is it visible to all of you or not? Is it visible? No, it's not visible. Let me make it big. So let me see how to make it big. Just wait. Oh, oh, oh. Yes. Just see only this part. First part, then I will show you the second part. Is it visible to all of you? Okay, let me show you this part. Focus on this part. Now is it visible, kids? This part. Let me make more big. Now just focus over here. High spin and low spin. First of all, do let me know, is it visible to all of you, kids? This much part, just this much. High spin, low spin, the lower part. The lower part only. Tell me in the chat section that yes, if this lower part is visible to all of you. Show me the green signal, kids. Show me the green signal. Okay, now see. Now see, kids. Now see. Low spin. Low spin means what? Low spin means what? Low spin means definitely strong field ligand. Low spin means strong field ligand. Can I say strong field ligand? Strong field ligand. Can I talk about strong field ligand? Now, strong field ligand, low spin, strong field ligand. That means if I talk about 5 electrons, T2G5, all the electrons are in T2G, the electron has not gone in EG. Can you see? Electron has not gone in EG. All the electrons are in T2G. Can you see, kids? All the electrons are where? All the electrons are in T2G. When the strong field ligand is there, all the electrons are in T2G. All the electrons are in T2G 5. So we have to multiply 5 with 4. 5 4 ja 20. So negative 2 point minus 2.0 will come. See, minus 2. And 2 are being paired. 2 are being paired. So 2p is there. 2p is there. Can you see, kids? 2p is there. Can you see, everyone? Now, if I say the same thing in high spin, if I talk about high spin, that means weak field ligand is there. When weak field ligand is there, then 3 will go over there and 2 will over there. And 3 4s are 3 4s are 12. That means 1.2, that is of negative, and Eg, that is 6 into 2, 1.2. So the sum will come minus 1.2 and plus 1.2. So the 0 sum will come out. Got it? This is a really awesome thing given in your Tamil Nadu State Board. How many of you got it? Show me the green hearts. If you're not able to understand, show me fire. Then I will tell you once again. Either green hearts or fire. They will tell me, they will let me know, understand that whether I have to explain it again or it's clear, kids. Yeah, 0.6 and 0.4 are being the standard values. They are being the standard values. Wow, that's really awesome, everyone. Now, if this much is clear, Baba is going to start with isomerism. Baba is going to start with isomerism. That's really awesome, really awesome. But before that, starting isomerism, we were about to solve this question, and that's why I have started teaching now. See, kids, this is the question on your screen. Just see the question and try to reply, try to give the answer of this question, kids. The ball is in your court. The ball is in your court, kids. Give the answer of this question. Then I will start isomerism. Answer it out, kids. What's the answer of this question? Guna is going for A. Guna is going for A, kids. Tetrahedral I will teach. Yeah, sorry, Rutika. After this, I will teach tetrahedral. Then we will come to the isomer. Sorry, Rutika, sorry. Most of the kids are going for B. Let me check it out. For D4 ions, the fourth electron enters in one of the EG. That means it is going in EG. What do you understand? Definitely, it is given an idea that the ligand is, what type of ligand is there, kids? What type of ligand can you think? Then the ligand is definitely weak field ligand, and weak field ligand can't do pairing, and can't do pairing. Understand what do you mean by can't do pairing? That means pairing energy is high, and pairing energy is high. And what should be the answer? What should be the answer? That pairing energy is high. So just see, pairing energy is high. What should be the answer? Pairing energy is high. Pairing energy is high. Got it? Everyone got it? This is very much clear to all of you. Now, what is the correct electronic configuration of the central atom in K4Fe based on crystal field theory? Wow, really awesome question. Everyone have to answer this question. Awesome question. Fantabulous question. Let's see who's going to give the correct answer of this. Really fantabulous. Let me see the answer of this question, kids. Fast, fast, kids. Fast. Fast. Very fast, kids. A. Sujita Murthy is going for A. Rest of other students, do let me know. A. Everyone is going for A. So let me check it out. First of all, K for efficient 6. Let me see the answer. K for efficient 6. That iron's atomic number is how much? Iron is 26. 26, just reverse 6 to 3d6, 4s2. Oxidation state is 2 plus. So iron 2 plus, that is ferrous. 2 electrons go on 3d6. 3d6 under the influence of strong field ligand, they will get paired. Once they got paired, 1, 2, 3, 4, 1, 2, 3, 4, they got paired. They got paired under the influence of this. So T2G6. So let me check it out. T2G6. We got the answer. We got the answer. Got it? Everyone is able to understand. That's really awesome. 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 Now, after this, okay, doing this question requires tetrahedral splitting. Now, Baba is going to tell you tetrahedral. CFT in tetrahedral. Are you ready? CFT in tetrahedral. Now, if I talk about tetrahedral compound, just see, if I draw metal over here, and if I draw tetrahedral compound, then definitely it will look like this. Just see, it will look like this. 1, 2nd, 3rd, and 4th. These are looking like tetrahedral. No, not looking like tetrahedral. Let me draw a bit. Yes, one ligand, one another ligand, 109 degree. So another ligand, 109 degree, and another ligand, 109. This is tetrahedral, and this is the way from which ligand is coming along with its electrons. These are the 2 electrons, 2 electrons, 2 electrons of the ligand. Now, you know that central metal atoms, those orbitals place will be, what's that place? Let me draw like this. This is x-axis, this is y-axis. If I say this is z-axis, okay, x, y, z. No, it's not looking x, y, z. So this is z-axis, this is x-axis, this is y-axis. Now it is okay. Now that Eg1 will be Eg1, Eg is z square, this is dz square lying on the axis away from ligand. Now if I say dx square y square, where they will lie? Dx square y square, dx square, they are lying over here, dx square, and the y square, they are lying over here. They are also away from the ligand. So who are nearest to the ligand? Now if I talk about dxy in between x and y axis, suppose this is x axis, that is y axis. So dxy will lie somewhere over here. Dxy will lie over here, and like dyz dx. So dxy, this is nearest to the ligand. That means I will say T2G, they are not on the path, they are not on the axis, but T2G are quite near to ligands, and no one, neither T2G nor EG, neither T2G. So here I will not use G. Why I will not use word G? There is no symmetry in the tetrahedral. So I will say T2 are quite, neither T2 nor E are on the exact way of ligands, not on the exact way of ligands. They are not on the exact way of ligands. So the splitting will be less. That's why tetrahedral splitting is less. Tetrahedral splitting is 4 by 9 of that of octahedral. Remember that. And that's why in tetrahedral complexes, low spin is very rare. Low spin is very rare. Low spin is very rare. Everyone got it? Then I will give you the question. Is everyone clear with this? Is everyone? Now see, are you clear with this? That means now T2G will go up and EG, not T word I will not use. T2 will go up and E will come down. In this, T2 will go up and E will come down. Just try to solve this question. Answer it. Answer it. Not exactly opposite. Jia Uma, not exactly. Yeah, it will be taken today, Rekha. After this, there will be break and then I will start telling you isomerism after break. Lunch break, after lunch break, I will teach isomerism and synergic bonding. Good, very good. Right now, I have told you one formula. CFSE, crystal field stabilization energy, octahedral and tetrahedral. So tetra is, what I have told you, tetra is 4 by 9 of octa. How will you learn it? How will you remember it? So 4, 9, fortnight. How to remember? Fortnight. You make R silent, fourth night. Fourth night. F, fourth night, 9. So that is given 18,000. 18,000 and 4 by 9 of that. So 9 twos are, 9 twos are and 4 twos are 8,000 centimeter inverse. Clear to all of you? Is it clear? So kids, there is a break. Right now it is lunch break, kids. Right now it is 3:06. Let's meet at 3:40. Okay. Then I will teach you isomerism. I will tell you the fundamental things about isomerism. Most advanced technique how to find out geometrical and optical isomerism the best way. I will tell you 3 ways. Whatever you like, you can go with that. And after that, I will teach DNF block. First, isomerism of coordination chemistry. Then, after isomerism, synergic bonding. After that, John Taylor distortion. After that, trans effect. Then coordination chemistry completed. Then I will start DNF block. Is it clear, kids? Are you okay with this? Are you getting what I am telling you, kids? So there's lunch break. Let's meet at Let's meet at what time, kids? Let's meet at 3:40, right? 3:40. We will write at 3:40 with same energy. Come with same energy, kids. Come with more energy, because after doing lunch, your ATPs will get increased, right? Come with more energy. Is it clear, kids? Yeah, after D and F, I will teach P block. Sausi, thank you. After D, I will teach Bhavani P block, okay? Don't worry. Welcome back again. Just to let me know, my dear students, have you had your lunch? Now, can you hear me? Can you see me? Yes? Show me the green signal. I want to see green hearts in the chat section. Now, I hope that everyone is full on energy and everyone can hear me, can see me. So, after this lunch break, I want to see green hearts that I'm audible and visible to each and everyone. And we are going to deal with isomerism. Isomerism, very, very important, very, very important. Isomerism. In this isomerism, we will discuss about isomerism of coordination number 4. In coordination number 4, we will have two things. One is being sp3 hybridized, another one being sp2, or you can say sp2d, better to say tetrahedral and square planar. Here we are going to deal with tetrahedral. Here we will talk about square planar. There are geometrical isomerism and optical isomerism. But before telling you in detail, coordination number 6, that means octahedral, that means whether it is being D to sp3 inner orbital or sp3d2. So their geometrical and optical isomerism we will discuss in detail. But my dear students, everyone is there. Now see, first of all, let me tell you, they will never show GI. sp3 tetrahedral can't show GI, can never show GI. They can show GI and optical isomerism. They can never show. They are never optically active. Can't be optically active. Why can't be optically active? Because they have plane of symmetry. Can't be optically active. It can't be optically active because they have plane of symmetry. Now, so this is a major chunk, means majority of the things will come from here. Their geometrical isomerism, total number of GI they will ask, and total number of optically active isomers. Total number of optically active isomers. We'll discuss in detail. So are you ready? I want to see in the chat section that everyone, show me in the chat section that everyone is ready. My dear friends, after telling you this isomerism, I will let you know synergic bonding, then John Taylor distortion and trans effect. After that, D block, F block, and then P block. So are you ready? Show me some fire in the chat section that yes, you are ready for that. Green hearts and the fire in the chat section. I want to see kids that. Let me check it out whether everyone is ready or not, my dear students. Yes, yes, everyone. Fast, fast, fast. I want to see fire in the chat section. Fast, very fast. No. So, see, my dear students, if I say, if any complex is like this, there is central metal atom. If I say there is being central metal atom, kids, there is central metal atom and surrounded by ligands. Suppose if I say there is one ligand, there is one ligand. Before telling you this thing I'm going to draw, let me tell you that thing. Square planar complex. Let's see square planar complex. Square planar complex. The square planar complex with coordination number definitely 4. And if I say there is Ma4, means all the 4 ligands are same, can never show GI. Ma3b, 3 ligands are same. Either you can write like that, or some people will say, I want to write like AB3. They are same. They can't show GI. Can't show. Now, why they cannot show GI? I will explain it. First, see who can show GI. Ma2 P2, that means 2 ligands are same and 2 are different, they will show GI. MAB, or you can say Ma2 BC, they will show GI. If I write MAB CD, all 4 are different, they will show GI. GI, yes, they will show. Now, question arises how they will show GI. We want to understand that. Now, see kids, if I say there is central metal atom and one ligand is chlorine, another ligand is chlorine, another ligand is bromine, another ligand is bromine. This is being square planar complex. You can understand. Think square planar complex. Can you see? This is being a square planar complex. Is looking like or not? Yes, like being square planar complex. So my dear friends, you can see here clearly that chlorine is vertically opposite to chlorine. This chlorine is just opposite, means at 180 degree with respect to that chlorine. That means they are anti to each other. So we'll say this is trans. And if I write like this, M Cl Cl Br Br. Now you can see that 2 chlorines, they are definitely at what degree? 2 chlorines are at 90 degree to each other. Can you see the angle? This is being 90 degree. So we will say they are cis. I hope this point is very much clear to each and everyone. What is being cis and what is being trans? So cis trans is clear to each and everyone. If yes, show me the green hearts that yes, so very clear. This is simple. Nothing is to understand in this, but keep on showing green hearts so that I can make it clear in my mind that everything is clear to all of you. Now, my dear friends, see, if I say I'm provided with M, A, B, C, D, all 4 ligands are different. All 4 ligands are different. All 4 ligands are different. Meaning of this is that. Now, if I draw 4, 1, 2, 3. If I write down central metal atom over here, central metal atom over here, central metal atom over here, and let me make A to be fixed at this place. Now, just in front of A, I can write B. Just in front of A, I can write C. Just in front of A, I can write D. These are the possibilities. If you want to try, you can try in front of this. I have written this in front of this. I have written this in front of this. I have written this. No, if they are means in front of each other, then definitely it means something else will be in front of each other. Rest of the things are like this. Just see to it. Let me put it over there. That means AB, CD will be over here. AC, DC will, DB will be over here. AD, so BC will be there. These are the 3 possibilities. If you try to draw anything else, I don't think you will be able to draw. Total number of GI, number of GI is being 3. 3 is the answer. 3 is the answer, my dear student. 3 is the total number of GI. There are 3 GI. Got it, everyone? Just to let me know in the chat section. If you are able to understand this thing, then only rest of the things you can understand. Otherwise, you will never be able to understand rest of the things. This point is very much clear. Then only you can, wow, Sahana, very good. Now, my dear student. Now, suppose if I am having something like a square planar, and if I cut it like this, whatever the atoms are placed over here, atoms are placed over here. here, all the 4 atoms, whether they are same or different, whether they are being same or different, you cut it like half of the atom will go up, half of the atom will go down, half of the atom up, down. So plane of symmetry is there. Can you get it? Plane of symmetry. Always there will be plane of symmetry. So compound which shows a square planar can never be optically active. Plane of symmetry will always be there. Plane of symmetry is there. So optically inactive. Optically inactive. These compounds are optically inactive. So from here, we will move towards octahedral complex, because that is really very important. If everyone is ready for octahedral complex, just see. Octahedral complex, what I am going to do, kids, first I will give you one table. In the form of table, I will draw one table. I will explain octahedral complex in 3 ways. How many ways? 3 ways. First, table, you can cram the table. Second, I will let you know visualization method. So 2. And third, I will tell you grouping mechanism, grouping. So first let me tell you how I will explain. So octahedral complex, octahedral complex, GI and optical activity, I will explain in 3 ways. How many ways? 3 ways. What are these 3 ways? 3 approaches. 3 approaches are: approach number 1, table, that is the cramming part. Cramming, you can answer it. Second, visualization, that is knowledge part. Third, by grouping. Grouping means hybrid model. Hybrid model of what? Hybrid of this. Hybrid of this one and this one. Intermediate. So I am going to explain these things in this way, right? See, kids. So let me write down type of complexes here. First, type of complexes, total number of GI column, total number of enantiomeric pairs, right? We need what? Type of complex, total number of GI, enantiomeric pairs, total number of enantiomeric pairs, enantiomeric pairs. Can you see? Is it visible to all of you? What I have written? What I have written? Once again, let me write down and tell me in all the columns what I have written, kids. Do let me know. Everyone do let me know what I have written. Everyone do let me know what I have written. Do let me know, everyone. In the first column, what I have written? Tell me. Complex type. Complex type. Second, what I have written? Number of GI, geometrical isomers. Third, what I have written? Number of enantiomeric pairs. Enantiomeric pairs. Number of enantiomeric pairs. Tickets. Let me put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now see kids, type of compounds I'm going to write. You have to help me. I need your help kids. M A6, all 6 ligands are same. M A5 and definitely be M A4. Now it can be B2 or it can be MA4 AC, nothing else. Now let me change the color. Now if I write MA3, then number of things are possible. B3, MA3, it can be B2C, MA3, it can be BCD. All 3 possibilities are there. Now if I write MA2, and it can be B2, can be C2, can be MA2, then B2CD. Now MA2, it can be BCDE, and last one but not the least one, MABCDEF. All they are different. So how many possibilities are there? I think it's the team of Indian player, 11 team player. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Can you see? 11 members team. Can you see everyone? Till now, everyone is clear. Show me some fire in the chat section. Show me some hearts. Now see how to learn it, because cramming is also an art. Cramming is also an art, kids. Cramming is not easy job. Cramming requires brain. 0, 0, 2, 2, 2, 0, 0, 2, 2, 2. Now see, after 2, 3, 4, 5, 6, and 6 opposite is 9, and then 9 plus 6 is how much? 15. Has it gone to your brain? 0, 0. Let me check it out. 0, 0, 2, 2, 2. 2, 2, 2. How many times 2? 3 times 2. Now, after 2, 3, 4, 5, 6. Opposite of 6 is 9, then 15. Now, here, 6 times 0. 0, 0, 0, 0, 0, 0. 6 times 0. Now, here 1, then 2, and then 6, and then 15. That's it. This is the cramming part, kids. This is the cramming part. This is the table. If you want to go with this table, it's fantastic. Now, let me tell you the visualization part. That will require brain. And after visualization, I will give you in between cramming and visualization. Fantastic approach. So, is it clear to all of you till now? 15 plus 15, that means total 30 optically active isomers. Now, my dear student, after going with that, let me show you the visualization part. Just see, visualization will require brain. Visualization method. Visualization method. Now, it will require brain, kids, right? Are you ready? Just see, if I say that I have drawn something over here and I have written central metal atom at this place. Now, if I say that here is A, okay, let me say all 6 are different. M, A, B, C, D, E, F. This is the toughest one. You can see this is the toughest one. It was having 15, 15. So this is the toughest one. Let's start with the toughest one only. So if I say I have taken here F, F is fixed, and in front of F, E is there, E is there. Now, at these 4 positions, what I can write? I can write A, and in front of A, I can write B, then C, then D. B, then C, then D. How many are they? They are total 3. Now, whether they are having plane of symmetry or not, now they are not having plane of symmetry. See why? If I was having square planar complex and I was cutting it, it was getting divided in 2 equal parts. But now I'm having upper side something else, and I'm having lower side something else. Up and down, they are not being same. So if you cut it, sandwich cut, upside it's the stylus and downside it is the bottle. They are being different. Never you are going to get plane of symmetry. This point is clear. First of all, do let me know. Otherwise, once I'm going to tell you each and everything, at last you will say, sir, I'm unable to understand. You will talk like that at the last. So right now, tell me, if there is F, there is being F, and there is being E, they are being different. So if you cut it, no plane of symmetry is there. No plane of symmetry means all these 3 compounds are optically active. Why 3? Now you will ask, why 3, sir? How they are being 3? They are 3. Once in adjacent to A, I am keeping V, then C, then D. This already I have explained in square planar complex. Now 3 will form 3 mirror images. They will have mirror images. Let me keep mirror over here, water or mirror, like this. 3 mirror images. Definitely, my dear students, this is the mirror. Mirror, so mirror images. If they are not having plane of symmetry, definitely no plane of symmetry they will be having. So 3 enantiomeric pairs we have got. This thing is clear to each and everyone. If yes, show me green hearts, then I will move ahead. First of all, if this much is clear, if not clear, you can show me fire. If it is clear, show me the green hearts, kids. Because Baba is here to teach you, to make it clear. So your green hearts or fire will tell me whether this is clear or not. Fast, fast kids, fast. Rose, Tina Mandal, yes. Sahana, thank you. Sahana, thank you. Sausi, Ruthika is there. Baba is really doing hard work, kids. All everyone. Thank you. Sahana, yes, thank you. Baba was not feeling good. Then also Baba is taking class. That's really fantastic. Now, kids, now what I am going to do, see what I am going to do. I am taking another compound, and in this compound, what I am going to do, I am taking here F only, but in front of F, I have changed. In front of this F is constant. In front of F, I have changed. In place of E, I have done D. Now what you are going to get? Now, in front of A, there will be B, C, and E. Once again, you will get 3. Central metal atom, you will get 3 enantiomeric pairs. 3 enantiomeric pairs. Right? Now, you are able to understand. Once again, what I will do? Once again, I will draw one more, then one more, then one more. Total 5. Why 5? Just see. Just see to it. In front of F, F is constant. F is constant. You can do anything constant. Why to waste time? So I have taken 1. F is constant. In front of A, I have written what? In front of A, I have written C. In front of F, I have written B, and in front of F, I have written A. Now, all they are forming how many complexes? Just see to it. So, FC is there, so there will be A, and in front of A, there will be B, D, E, and here A, in front of A, there will be C, D, E, and here will be note A is already there, B, in front of B, C, D, E. You can take anything. So, all they are forming 3, 3, 3. 3 enantiomeric pair, 3 enantiomeric pairs, 3 enantiomeric pair. Total, how many enantiomeric pairs you have got? All in all, how many enantiomeric pairs you have got, kids? Do let me know. 3 5s are 15. Can you see 3 5s are 15, kids? 3 5s are 15. 3 into 5, that is coming out 15 enantiomeric pairs. I hope this was clear to all of you. If you liked it, show me the green hearts. Yes. Now, the grouping method. I'm going to tell you grouping method because this visualization is not for everyone. Everyone can't visualize it. Everyone is not having that visualization power. So I'm going to intermediate level. Just see what's that. What's that? So see, kids, first let me explain total number of geometrical isomers, how to find out total number of geometrical isomers for calculation of total number of GI. So this is grouping method. Now, take any example. Whatever the example you want to take out of these, you can take any example. Let me explain any example. You can select any example. Anyone. Whatever the example. Let's say MA3BCD. MA3BCD. Okay. MA3BCD. Right? MA3BCD. Let me take MA3BCD. So let's make groups. This is M. If I write A2, then what type of grouping can be done? MA2, BC, and I can write AD. So MA2 only. Now AD is there. AB will be there. If AB is there, then here will be C, D. Now with A, D is there, B is there, C can be there, A with C, MA2, what is left? B, and D is left. With MA2, I have made 3. Now what else I can do? They are different. One is different from second, is different from third. Now if I want to make anything else, now A can go along with 3A, with can go along with like that, M, AB, AC, AD. Am I right or not, kids? So 4 GI are possible. Total 4 GI. Total 4 GI. If you want to make any other combination, that will get repeated. This is the grouping. Now let me see how many of you are liking grouping method. Grouping method. Do let me know in the chat section how many of you are liking this grouping method. Now you must be asking, sir, how to find out whether optically active or not. These are the 4 GI. Everyone, fast. Baba is really doing hard work, lot of hard work, kids. Okay, Saucy, everyone, you have to write down which method you are liking most. Okay, now see. Which one is optically active? For optically active, see, for optically active, for optically active, for optically active, for a compound to be optically active, what is required? Just see, two things are required, two conditions it should fulfill, two conditions are required. Condition number one, PP. PP stands for perfect pair. You know perfect pair. What is the meaning of perfect pair? Perfect pair means in pair they should be different. Just see, AB is perfect pair, BC is perfect pair, CD is perfect pair. What is not perfect pair? If I write AA, not perfect pair, BB, CC, they are imperfect pair. One thing. Now, second point is required, kids. PP should not get repeated. PP no get repeated, should not get repeated. If these two things are there, then the compound will be optically active. Then the compound will be optically active. Just see, right now we have gone with Ma3PCD. So we formed like Ma2 ABCD. We formed like Ma2 ACBD. We formed like Ma2 ADCB. We formed like MAB ACAD. Now kids see, this is not perfect pair, this is not perfect pair, this is not perfect pair, this is perfect pair and no repetition. So this one is optically active. Can you see? This one is optically active. This is really awesome. If you liked it, do let me know. Out of four GI, only one is optically active. That I have written in the starting only. One, no, not one optically active, one enantiomeric pair. It will form enantiomeric pair. It's enantiomer means if it is dextro, it's so one pair is optically active. Better to say one pair is optically active. One pair, one enantiomeric pair. One enantiomeric pair is optically active. If you got it, show me the green hearts, kids. Really, I've told you a fantastic thing which holds a hell lot of weightage. Do let me know, kids. Everyone, do let me know, kids. And put the green hearts. I want to see. I'm not. Smash the like button. Smash the like button. Make it 650, kids. Make it 650. That's really awesome. Now, this is completed, done and dusted. Now I'm going to tell you what Baba is going to tell you, kids. What? Just to let me know what Baba is going to tell you. Let me remove my shoes. Just a second, kids. Just a second. What I was telling you, kids, what I was telling you, that after this, I will tell you synergic bonding. Synergic bonding, or should I tell you JTD, John Taylor distortion? First of all, let me tell you John Taylor distortion, right? John Taylor distortion. John Taylor. JTD effect. That is John Taylor distortion, not given in NCERT, but number of times they have asked. What is that? When we draw this is observed in octahedral complex. Octahedral complex. Now see kids, when we draw octahedral complex, they look like this. This is the central metal atom. One ligand, another ligand, another ligand, another ligand, another ligand, another ligand. 6 ligands. And their bond lengths are being same. Can you see? This is the ideal condition. And you know that ideal condition is very rare. So if the ideal condition is not over there, there will be distortion. And which place distortion will be? Let me tell you, distortion will be at which place. If I say like this, if I say that central metal atom and this is the place for ligand, metal ligands. Now, if I say here is being central metal atom, this is ligand, this is ligand, this is ligand, this is ligand, central metal atom, this is being ligand, this is being ligand, this is being ligand, this is being ligand. Now this place, either it will become elongated than the normal one, large, lengthy, or it will become short, dwarf, small. So this is known as distortion. Either it will become lengthy, more length, or it will become dwarf. Dwarf means shorter. Now, what type of question they will ask in this distortion? What type of question they will ask? So this will happen due to unsymmetry. If symmetry is there, in case of symmetry, it will be like this, symmetry. If it is being unsymmetrical or asymmetrical, better to say asymmetrical. In case of asymmetrical, it will be like this. Now, for this also, there are two ways. One thing I will explain, another thing you can learn it, you can cram it. Two things. See, first cramming part, if you go and if you cram it out, then remember 1947, it has JTD, John Taylor distortion is there in 1947, a love story, 1947, the Freedom Day. This is the trick. Now, let's see how and why. Let me take fourth electron. If I say fourth electron is there, and if I have T2G and EG, just see, this is T2G. I say this is T2G, this is being EG. Splitting T2G and EG. Now, if I want to fill 4 electrons, if strong field ligand is there, I will fill 4 electrons like this under the influence of strong field ligand. If weak field ligand is there, how I will fill? Weak field ligand is there, I will fill like this. 1, 2, 3, and 4. You see, under the influence of strong field ligand, under the influence of weak field ligand, in both the two ways, there is asymmetry. Symmetry can't be achieved. Can you see? This is being EG, being T2G, being EG, that is being T2G. Can you see? For the fourth electron, this is also asymmetric, this is also asymmetric. Can you see? In this way, you can fill 9, 4, 7, whatever the electrons you want to see, there will be distortion. I think this is clear. So this trick you have to remember, 9, 4, 7. there will be distortion, whether the ninth electron or the seventh electron or the fourth electron or the first electron. Even if the first electron is there 1947, then asymmetry will be there. Are you getting my point? Everyone getting my point? Now, this point is clear to each and everyone. Now I am going to tell you synergic bonding. Synergic bonding. Now, why I have not considered one? Why I have not considered one? Why I have written at the last? Because if the electron is going to that, that effect is more dominating, and that's why that is more required. Now, let me tell you synergic bonding. Synergic bonding. Synergic bonding is also known as back bonding. Also known as back bonding. Now let's see what happens over here. If I talk about CO, and if I talk about the CO, you must have heard what is the bond order of CO. Can you please let me know bond order of CO? You must calculate it like this: 6 plus 8, 14, and the bond order is 3. You know very well, if the bond order is more, then the bond strength is more, then the bond length is less. This thing you know very well, kids. I hope that you know very well. Now, if I say that's its anti-bonding ABMO is vacant. If I talk about its ABMO, that is vacant. Anti-bonding molecular orbital is vacant, that can accept electron. Now, if I say that is bonded, this one is bonded with metal, central metal atom, and it is acting as ligand. It is donating, it is acting as ligand, in metal carbonyl compounds, donating lone pair, lone pair to whom? Donating lone pair to central metal atom, central metal atom. Now, central metal atom will have number of orbitals. Now, what central metal atom will do, kids? Just see. Central metal atom will be having electrons in its orbit, electrons, and this electrons back donation. This back donation is known as synergic bonding. This friendship, this new friendship, this friendship is known as back bonding or synergic bonding. This friendship is synergic bonding, kids. Now, there was one friendship, old friendship. This was the old friendship, kids. Are you getting my point? This is the old friendship. That is the new friendship. Now, as this friendship, new friendship is getting matured, new friends, if the new friends are becoming more close, how they will become more close? When the central metal is donating electron, when central metal atom is donating more electron, is donating more electrons, the new friendship, write down properly, sorry kids, when central metal atom is donating more electrons. Are you getting my point, kids? When central metal atom is donating more electrons, you can consider it to be like this. This is wife, this is husband. In dowry, the wife has given money, and now for shopping, wife is gaining or taking back its money. Now, when this husband is donating more, when husband is donating more electrons to wife, then they will feel better, and the wife will say, okay, parents, I'm okay. This parental friendship. Now, are you getting this point? See, in CO, carbon, oxygen, oxygen was the parent, this was the girl got married to CMA, now given some money and now taking back its money. Now, as this friendship between this CMA and wife is getting matured, more closeness, then this girl will say, okay, parents, bye bye. And if it is not donating money, be more close to that. This story, are you getting? Can you correlate? Now, when central atom is donating more electron, the new friendship, this is new friendship will be better. If you liked it, if you like this story, do let me know. New friendship will be better. New friendship will be better. New friendship will be better. And if new friendship is better, bond order of new friendship will increase. Bond strength of new friendship will increase. Bond length of new friendship will decrease. And if they are becoming like this, then the old friendship, bond order will decrease, bond strength will decrease, bond length will start increasing. Now, how the question will come in your exam? If this is clear, show me the green hearts, then I will give you question. Just see what type of question will come. Question will come like this. Arrange the following. In decreasing bond order of CO. A is MnCO whole 5. B is MnCO whole 5. Negative. C is MnCO whole 5 positive. So let's see whether you understood or not. If you understood, you have understood, your answer will be right. Do let me know. Do let me know, kids. Fast. Everyone, do let me know. I'm waiting for your answer. Everyone, Baba is waiting for your answer, kids. Do let me know. Kausi is going for C. Okay, let me check it out. You see, this is donating maximum money. This one is because negative charge means maximum rich. This is maximum rich. So this friendship will be best and CO bond order will be least. Here, CO bond order will be least. Ready? Agreed? Now, this is poor guy, positive charge, positive. So, poor guy, very poor friendship. So, this friendship will be best. CO bond order will be maximum. Now, arrange the following in decreasing bond order. So, CA, B. How many of you understood? Do let me know. How many of you got it? CAB. CAB is the answer. Do let me know, kids. CAB is the answer. How many of you got it? How many of you got it? Do let me know. How many of you got it? Very good. Kausi, fantastic, fantastic. Yes. Now see, now only one thing is left. One thing is left. What's that? What is that? Trans effect. Now kids, first of all, do let me know, Baba has not skipped even a single thing. So lengthy chapter, so big chapter, which holds a whole lot of weightage, that Baba has told you each and everything or not. Do let me know, Baba has told you each and everything or not. Do let me know. Now kids, trans effect. This is also not given in NCERT but important. Trans effect. What's that? Trans effect, kids. If I talk about trans effect, first of all, we should know trans effect series. No need to cram it, but you should have an idea about trans effect series. Just like a spectrochemical series, there is trans effect series. You should have a little bit of an idea about it. What's that trans effect series? Canada, Colombia. Now, number of things are there. Naughty bro, Sachin is Indian Bruce Lee, is Indian Bruce Lee. Canadian Colombo, naughty bro Sachin is Indian Bruce Lee. After that, is playing with Neha in water. Playing with Neha in water. This much is okay. Playing with Neha in water. What is the trick, kids? What is the trick? In Canada and Colombo, naughty bro Sachin is Indian Bruce Lee playing with Neha in water. Playing with Neha in water. Now, what type of question will come? See, suppose they have given compound like this square planar complex. There is central metal atom, and if I say there is chlorine, there is NO2, there is ammonia, there is ammonia, or if I say there is chlorine, chlorine, and now ammonia has to enter inside it. Now, out of chlorine and NO2, who is stronger? Trans effect. Who is having stronger trans effect? Let me know in the chat section. There is chlorine, there is NO2. Who is having more trans effect? Definitely this is having more trans effect. So whomsoever is against it, who is against it? Chlorine is against it. This will get replaced with ammonia, and the new compound will look like this. This is NO2. This is central metal atom. There will be ammonia, and this will go. Who will eliminate out? Whomsoever is trans opposite to this strong field ligand will get eliminated out. Only this much you have to know. Everyone got it? Do let me know if you understood. Did you understand? Have you understood? Do let me know in the chat section. Show me the green hearts if you got it, kids. In this way, the whole coordination chemistry got completed. Now Baba is going to move towards T and F block elements. After that, P block, and then it will get completed. Fast, kids, fast. I want to see fire, hearts, green hearts in the chat section. Make it 650 kids. Likes are less. Make it 650, then only I will start. Ausi, thank you. Make it 650, likes 650, then I will teach you kids. 643 only. Okay, now if you're ready, show me the fire in the chat section. I was going to start with D and F block elements. D and F block elements. Before I start D and F block, we should know the exact position of elements, otherwise we can't do anything. We should know, to understand it, we should know exact location of elements. Okay, are you ready? Now see kids, where they are located. Let's see. If I say that I'm having alkali and alkaline earth metals elements, do you know alkali and alkaline earth metals, where they are located, how they are located? 1, 2, 3, 4. Will go like this. Fifth will go like this. 6 will go like this. Right? 7th will go like this. This is the periodic table. Now, just see. If I say there is hydrogen, leave it hydrogen, lithium, hidden Lena knows, ruby sees in France. Hidden Lena knows, ruby sees in France. Beryllium, magnesium, calcium, strontium, barium, radium, right? This much we know. And here, just see, this is the 4th period, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. Now see. Science teacher, very crazy man. Science. Hey everyone. Science teacher. Science teacher. Science teacher. Very crazy man. Felt cold in night with cousin. Felt cold in night with cousin. I have drawn this a bit broader, kids. There must be some reason. There must be some reason. I've left a space over there. Can you see the space? Space I have left. Can you see, kids? The space I have left. Now, before I start, let me tell you this: zinc, cadmium and mercury, they are not considered as transition elements. If you call them transition elements because they are very soft, they have n is equal to 0, so they are soft, so not to be included in these transition metals. Now, if I say scandium, scandium just below, first write down the atomic number 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Exceptional configuration. This is having exceptional configuration, having exceptional electronic configuration. Now below this scandium, YLAC, skylax. Everyone says skylac or skylaces. Everyone says skylaces. Skylaces. Now Kaiser is on half of roof. Skylaces, Kaiser is on half of roof. Okay, now see kids, why I have left this space. If you see, this is 58. Lengthen is atomic number 58, right? No, 57, 57. And this is 72. How much difference is there? 57 to 72. How much gap? How much gap is there? This is 89, 104. How much gap is there? How much? 72 minus 57. Do let me know how many elements are missing. Do let me know how many elements are missing. It's fast. Write down how many elements are missing over there. 15. Just check it out. 15 or 14. Amruda. Just check it out. 15 or 14. Everyone just check it out. 15 or 14. Kid. Do let me know. 15 or 14. 14 elements. Now, 14 elements over here missing. At this place, 14 elements are missing. And here also 14 elements are missing. These are known as 14 elements lanthanoids. And these are known as 14 elements actinoids. And they haven't got position over here. That's why where they are kept, they are being placed at the bottom of this. They are placed over here, kids. 14 elements. These are F block elements. These are being F block elements. '58 to '71. 58 to '71. 90 to 103. You should know positions, then only you can understand. These are very, very important. They are going to change the game. Remember, these elements, they are going to change the game, kids. They are game changer. They are placed over here like bomb. They will change the game. They are going to change the game, kids. They will change whole game they will change, kids. So we have to be careful. They are like, what to say? They are like very dangerous. They are very dangerous, kids. Now, kids, how they will change the game? They will do lengthenoid contraction and actinoid contraction. And lengthenoid contraction, actinoid contraction will change the whole game of this whole series, each and everything. They will be responsible for what? They will be responsible for lengthenoid contraction and actinoid contraction. Lengthenoid and actinoid contraction. They will be responsible for lengthenoid and actinoid contraction. This I will explain what is lengthenoid and what is actinoid contraction. I will tell you each and everything in detail. Now, before that, let me tell you, my dear students, these two elements are very, very important. Its group is 6th because it is having 2 plus 4, 6 electrons in the valence shell. So it will have maximum oxidation state of plus 6, and 2 plus 5, that is 7. Manganese will have maximum oxidation state of plus 7. Now, what are their stable oxidation states? Which one will be better reducing agent? Which one will be better oxidizing agent? That the examiner will ask. Why they are having such type of oxidation states? How many things? And what? Oh my God, who is there? Srinath. Oh, welcome, Srinath. Srinath, I have seen your green hearts. Thank you, Srinath. Thank you, thank you, thank you. Now, see, kids, let me move with their what. Okay, before I go towards that, how many of you want to understand what is the key role model of these lengthenoid contraction? Let me tell you here, and how they will do the contraction. The size of zirconium and hafnium is almost same. Because of this lengthenoid contraction, I will say zirconium's size is 160 picometer and hafnium size is 159 picometer. As we go down the group, as we move down the group, the size should increase. Here the size is increasing, here the size is increasing, here also the size is increasing, but here the size is increasing only up to here, only up to here. These, they will have almost same size, almost same size. Why? Because of this contraction, lengthenoid contraction, the size will become almost same. Of who? 5th and 6th. That means 4D is 3D, 4D and 5D element size is almost same. Can you see? Because of lengthenoid and actinoid contraction. Now, what is lengthenoid and actinoid contraction? Let's see. Lengthenoid and actinoid contraction. Just see how to understand. First of all, we have to understand, if I say that I'm having something like S. This is S. This is P. This is D. And this is F. Sir, once again tell us. It's not, I'm unable to understand. Okay, this is S. This is P. This is D. This is F. SPDF. S, P, D, F. Now these are the clothes. You can consider them to be clothes. Now see type of clothes. If I say S cloth is like this. S cloth is like this. P cloth is like this. D cloth is like this. F cloth is like this. Now, if in between you and the sun, these are the clothes who can protect you maximum from the sun rays. You are wearing out such type of clothes who will act as better screen, or you can say these are the windows of your house who will protect you maximum from S. So it is having maximum screen. It will act as best screen, maximum screening effect. So best, or if it is your, I will say protecting, something protects you. So best shielding effect, best shield. Avengers game if you are going to play like that. And these two are duffers, means poorest shielding effect. Now my dear students, screening effect is like this. Now if I say that I'm having nucleus, in the nucleus this is positive proton, and outside that the electrons are moving. The electrons are in the outermost orbit like this. The electrons will be like this. First orbit, second orbit, third, fourth, fifth, sixth. Now in first there is no D, in second there is no D, in third there is D, 3D, in fourth there is 4D, and in fifth there is no, in fourth, third, 3D is there but it is not over there. In fourth orbit it will start 3D, in fifth 4D, and sixth 4F, 5D. So if I say there is electron located over here, and this nucleus will put over there force of attraction. This force of attraction will go like this. It will get cancelled out over here. It will get cancelled out at this place. But here it will not be getting cancelled out that much, because 4F screening is very poor. Very, very poor screen. This is acting as poor screen. So the outermost electron, you know that in between this and electron there is force of attraction. In between electron and electron there is force of repulsion. So the force of proton is going and not that much getting cancelled out because of very poor screen. Very poor screen. This electron is getting maximum force of attraction, experiencing, getting maximum force of attraction from the nucleus. So it will come closer to the nucleus, will come closer to the nucleus, and it is coming closer to the nucleus. There will be shrink in the size of atom, shrink in the size of atom. That for each addition of electron, size will keep on decreasing, keep on decreasing, keep on decreasing. This is known as lengthenoid contraction. Got it, kids? How many of you got it? What is lengthenoid contraction? Show me the green signal, then I will tell you rest of other things. Kids, do let me know in the chat section. Do let me know, kids. How many of you got it? How many of you understood, kids? Do let me know. Show me the green hearts, kids. Fast, fast, kids. Very good, very good. Okay. Sahana, thank you. HSP, Sachin, Neha. Now, see, kids. If I tell you, science teacher, very crazy man, felt cold in night with cuisine. Now, kids, if I say here the oxidation state +3 is more stable, it will show only one oxidation state, and here +2. Now, if they are asking which element of transition will show only one type of oxidation state, they will ask question. They will ask question, which transition metal will show only, because they will show number of types. They will show variable oxidations. They will show variable. I will show you. I will tell you. They will show variable oxidation state. Many oxidation states. They will show many oxidation states. That is known as variable oxidation state. So question is, which transition metal will show only one type of oxidation state? Do let me know, kids. What's your answer? I want to see your answer in the chat section. Do let me know. What's your answer? Fast, fast. Fast, kids, fast. Fast, 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 kids, fast. Amruda is going for scandium and zinc. Scandium. So correct answer is being scandium only. Why scandium? Why only scandium, not zinc? Because it is not considered as not a transition metal. I have told you or not? Because it is very soft. No metallic bonding. No metallic bonding. Got it? Everyone, is it clear? So the answer is scandium only. Scandium is the correct answer. Now, once again, I have to write Science teacher, very crazy man. Science teacher, very crazy man. Felt cold. Night with cousin. Night with cousin. Now, +3, +4, +5, +6, +7, 2, 3, 4, 2, 3, 4, 5, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7. So these are their highest oxidation states. Highest oxidation states. Highest oxidation states. Coffee man, coffee, +2 and +3 are stable. Both are. From here, +2 oxidation state starts becoming stable. These elements, they have +2 oxidation state is stable. Before that, not stable. Now let me know why. Let me tell you why their +2 is not stable. Their +2 is not stable. Should I tell you? +2 not stable, and that's why they are good reducing agents. So they are good, very good reducing agent. They want to become what? All these elements, they want to become like noble gas elements. Noble gas, you know which elements? Noble gas. As I have told you in the starting, helium, neon, argon, krypton, xenon, radon. So by donating electrons, they want to gain argon. They want to become Arjit, A.R. Rahman. They want to become A.R. Rahman. So they all will donate that much electron, but manganese will say no. My +2 oxidation state is highly stable. So what he got, why he's talking like that? And chromium is saying my +3 oxidation state is highly stable. That means if I say manganese 3 plus and chromium 3 plus, if I take manganese 3 plus and chromium 2 plus, if I take like this zigzag, what I'm saying, just see. If I take chromium +2 and manganese +3, what is their electronic configuration? Just see. Chromium is having 24, so PD5, 4s1, 2 have gone, so 3d3, like 3d3. If I talk about this manganese 25, 5, 2, 3d5, 4s2, 3 have gone, 3d3. Both are having 3d3. But question arises, examiner will ask question, when both are having same configuration, why chromium 2 plus wants to try to become from chromium 2 plus to chromium 3 plus, wants to undergo oxidation? And why this manganese 3 plus wants to gain one electron to become Mn2 plus? This wants to undergo reduction. Why? Question arises, why? Definitely you will say this is oxidizing agent. And that is being reducing agent. Okay. Some people will say its +3 oxidation state is stable. Some people will say it's +2 oxidation state is stable, right kids? You will say like this. This question is given in NCERT also. But what's the reason behind it? Just try to understand. This question can also be asked like this, that why manganese +2 is stable and chromium's +3 is stable. Can be asked like this also, right? Any type of question can be asked. Now see what's the reason. If I say chromium, its configuration is like this: 3d5 4s1. After becoming Cr +3 will become 1 2 3d3. Can you see? I've taught you like this. This is T2g, this is Eg. Do you remember? Energy was increasing like this. Do you remember kids? T2g and Eg. Now one electron, one electron, one electron. There is symmetry, half-filled symmetry. Half-filled symmetry is there. Got it? So half-filled symmetry is stabilizing it. Half-filled symmetry stabilization is there. Everyone got it? Now, if I talk about Mn+2, why this is stable, then I will say manganese 25, reverse it, 5 2 3d5 4s2, remove 2 electrons, you will get 3d5. Now you can understand very easily that E2g having 3 electrons, E is having 2 electrons. Once again, symmetry is there. That's why it is more stable. So these are the reasons for stability, my dear students. Now remember one more thing. How many elements they are going to form metal oxide? They are amphoteric in nature. Then I will tell you most important thing. Amphoteric oxides. Amphoteric oxides. Remember that oxides of, Baba is going to give you a trick. Ashwarya Auntie, Caraminati. Ashwarya Auntie, Caraminati. Everyone say Ashwarya Auntie, Caraminati. Ashwarya Auntie, Caraminati. Everyone say Ashwarya Auntie, Caraminati. Ashwarya Auntie, Caraminati. Carry, you know, Caraminati. Caraminati. Particular oxidation state. Focus on the oxidation state. This is +3, this is +3, this is +3, +4, +4. That matters a lot. Their oxidation states holds a hell lot of weightage. Got irony victory. Got irony victory. Irony victory. Got irony victory. Now, jungle now these are the elements. Gallium also, aluminium. Now These are the elements whose any oxidation state. These 5 elements, 1, 2, 3, 4, 5, 6, any oxidation state, oxide being base amphoteric. What I am telling you, kids, there these particular oxidation states are, oxides are amphoteric, but here any oxidation state they are amphoteric. Suppose if I say lead oxide, PbO, PbO2, they all are being amphoteric, but here if I say it's 5 oxidation state, that will become acidic in nature, acidic. Now after telling you all these things, let me tell you potassium dichromate preparation kits, K2Cr2O7 preparation. This is really very important. K2, let me write down its color, original color, K2. Everyone agreed? K2Cr2O7 preparation. This is very important. Everyone ready? Now, for its preparation, what you are supposed to take, FeCrO4, Fe1, Cr2O4, 1 2 ka 4, 4 2 ka 1. Now, can also be written like this, FeO, Cr2O3, iron +2 oxidation state, chromium in +3 oxidation state. Can you see? Here FeO +2, chromium +3 oxidation. Now react it in presence of excess of oxygen and basic medium. What medium? Basic medium. Now before I complete this reaction, we should know some basics. If you don't know basics, you won't be able to do it. You have to cram it. The basic is that in one jungle there was living chromate. Chromate was there. Chromate was yellow colored chromate. The scientific story. Yellow chromate was there. He was always crying, "Hey God, why you have given me this color, yellow color? I'm not feeling well, I'm not feeling good." So once Hanumanji has come, Hanumanji said, "Hey chromate, you start eating acidic fruits. Go in acidic medium and start eating fruits. Fruits have acids, and your color will get changed and you will become double like me. You will become orange colored dichromate, K2Cr2O7, orange. Start eating orange, will get an orange colored dichromate." He was really feeling very good. Its color got changed. But then also, once he has got developing habits of taking some alcohol, basic medium, and in the basic medium, once again, he has returned to this side. So remember that acidic medium dichromate, basic medium chromate, reversible reaction. Can you see, kids? Can you see? Now, if you see, here also +6 oxidation state, here also +6 oxidation. The number of unpaired electrons is 0, but then also they are colored. So they are not colored due to DD transition, they are colored due to charge transfer spectra. Remember that. No unpaired electron. So no DD transition. So color is due to Charge transfer spectra. Charge transfer spectra. Both are tetrahedral sp3 hybridized, right? Now, my dear friend, I was telling you something else, and for that I required it. You see, it can oxidize to +3, it can go to +6 because its maximum oxidation state is +6. But +6, chromate or dichromate, remember that this basic medium will say you can't become dichromate, you have to be chromate. So what you will get? You will get K2 CrO4 Fe2O3 now carbon dioxide. Now, my dear students, that K2CrO4, if you add H2SO4, acidic medium, then what do you get, kids? In acidic medium, you can understand it will grow up because Hanumanji said you will become K2Cr2O7. Now, this potassium is large cation. Okay. My dear friends, one thing is there, already K2Cr2O7 I've got. So here if you use sodium carbonate, you will get sodium chromate. Why I am saying sodium, use sodium? Now you will say, sir, why we are using sodium? Let me tell you. Sodium carbonate, Na2CO3, you will get sodium chromate and sodium dichromate, Na2Cr2O7. Now you must say, sir, why? What's the reason? My dear friends, let me tell you one more thing. Bond of equality is good. Bond of equality is good. What's that? Bond of equality. That smaller cation, smaller anion, better bonding. Lattice energy will be greater than hydration energy, less soluble. And if I say larger cation, larger anion, better bonding, lattice energy is greater than hydration energy. Now, if I say opposite, smaller cation, color is this, smaller cation, larger anion, poor bonding, hydration energy will be greater than lattice energy, more soluble. Got it? Let me have a glass of water. You can also have it to keep yourself hydrated, kids. Hit the like button, kids, if you're liking it. If you're really enjoying it, kids, hit the like button. Now if I say by keeping all these things in your brain, just do let me know that sodium and potassium, who is bigger in size? And if I say chromate, dichromate, they are bigger in size. Larger anion. Then carbonate is also larger. Multi-atomic anion larger. Multi-atomic are always larger. So if I say there is sodium carbonate, potassium carbonate, who is more soluble in water? Large anion, smaller cation, large cation, large anion. So definitely sodium carbonate is more soluble, better soluble, right? That's why I said sodium carbonate we have to take. Got it? Everyone got it? So it was like this, sodium carbonate, so sodium dichromate. Now you can see Na2, smaller cation, large anion. Smaller cation, large anion means hydration energy is greater than lattice energy, more soluble in water. Now, this is the reason NCERT has written that sodium dichromate cannot be used for volumetric analysis because it is more soluble in water, so can't be used in volumetric analysis. So, can't be used in volumetric analysis. Now, if you react this sodium dichromate, it is not a good bonding. Why? Small cation, large anion, poor bonding. So give option with KCl. Now they will exchange K2Cr2O7 plus NaCl. Both will become happy ending. Large cation, large anion. That this can be used in volumetric analysis. So this is the preparation of potassium dichromate. Everyone got it? Now, potassium dichromate, let me give you one memory chart, very important memory chart, secrets, mind map. Na2, PrO4, acidic medium, Na2, Cr2O7, KCl, K2, Cr2O7, highly acidic medium, PrO3. Now their color, yellow, orange, red, all they have +6 oxidation state. Now, if you add NaCl to this and concentrated H2SO4, NaCl plus H2SO4, we will get reddish brown CrO2 Cl2 chromyl chloride gas. Now to this, if you add lead acetate, before that NaOH, you will get Na2CrO4, yellow solution. Now to this, if you add lead acetate, you will get yellow PPT lead chromate, PbCrO4, yellow PPT. This X, this Y, and this Z, all together known as chromyl chloride test. But it gets, this is really very important memory chart, will help you a lot. Now my dear student, let me tell you KMnO4. KMnO4, remember that KMnO4 is potassium permanganate, no, it's not visible, very bad, very bad, very bad, very bad, very bad, very bad, very bad. And I don't again. KMnO4. KMnO4. Remember that KMnO4 is paper. I call it paper. Pepper. Why? Because P for pink color, P is for purple color, R is for red color. And its name is potassium permanganate. What? Potassium PPR, permanganate. This is a trick to remember. Now see kids, if you supply acidic medium, very important thing I am going to tell you. If you supply neutral medium, if you supply faintly alkaline medium, means less basic, and if you supply strongly basic medium, here it will form colorless Mn2 plus. Here it will form MnO2 black color powder. And here it will form K2MnO4 green colored potassium manganate. Potassium manganate. So remember that here it has taken how many electrons? Here it has taken +7 to, it got changed to +2, and factor is 5. Here and factor is 7 to 4, 3, 7 to 6, and factor 1. So here its equivalent mass is equal to 158 divided by 531.6. Equivalent mass is equal to 158 divided by 352.7. Here equivalent mass 158 divided by 1, that is 158. Now, this thing is clear to all of you kids. Got it? Let me check it out in the chat section. Is this much clear to each and every one kids? Okay. Now, let me give you a short break kids. Short break for 20 minutes, tea break. Then we will meet at what time? Right now it is 5:30. We will meet at 5:50. Okay. Short break, tea break. Short break kids. Let's meet at 5:50. Okay kids. Okay kids. Is it fine? Say yes. Say yes kids. Because you need, right now D block is going on. D block. D block is on kids. Welcome back again, all my dear students. Just to let me know, everyone can hear me and see me. Am I perfectly audible and visible to all of you, all my dear students? Just to let me know. Everyone, hey everyone, all my dear students, welcome, vanakkam, suswagatam. Jo bole so nihal, sat sri akal, walaikum salam, assalamu alaikum. Now, see kids, let me remove here. No green signal, kids. Why? You can't hear me, can't see me. Do let me know, kids. No green signal. I think something is wrong. Can you hear me? Am I audible and visible, kids? If yes, I want to see green signal. I started checking my laptop that Baba is audible and visible. Yeah, you have delayed. Yes. Now it's okay. Now it's fine. Fantastic, kids. So I was telling you about their properties. Now see, if I tell you that what's common in K2Cr2O7, K2Cr2O7, the chromium is in +6 oxidation state and its stable oxidation state is Cr+3. So +6 +3, it would like to undergo reduction. Now see, +6 to +3. So it is SOA. SOA means strong oxidizing agent. Oxidizing agent. Now, if I talk about KMnO4, its oxidation state is +7, and from +7 it wants to undergo to +2. Now, +7 to +4 reduction. Who is better oxidizing agent? Just to let me know who is better oxidizing agent. It is given in your NCERT who is being better oxidizing agent. Kids, this is +7 to +2, so better oxidizing agent. Better oxidizing agent. Now, my dear student, one more thing is given in your NCERT, that CrO3, MoO3, tungsten O3. On moving down the group, their oxidation state, stability increases. Stability increases. Now, next, the most important thing, my dear students, remember one thing, that their size. If I talk about size, if I talk about size, then let me draw one boat. Baba is going to draw one boat. Just see the boat. It's like this. Will go like this. Now, what is the meaning of this boat? What is the meaning of this boat? Just try to understand. If I say this is atomic size, this is atomic number, then here is iron, cobalt, nickel, copper, zinc, cadmium, titanium, vanadium, chromium, manganese. So first it will decrease, then constant, then it will increase. Why? Their electrons are not parallel, means not pairing is not there, so no repulsion is there. But here the pairing starts, and then once again it will increase due to Z effective. Z effective will increase. So see, the size is getting decreased due to increase in Z effective. Then pairing started, then repulsion started. Increase and decrease is equal, and then it keep on decreasing. Now, my dear students, after all these things, let me consider the exceptional configuration. Exceptional configuration, my dear students. Everyone see the exceptional configuration. Just see. If I talk about in these elements, just see cerium to lutetium, cerium, praseodymium, now, my dear students, what I am going to tell you, exceptional configuration, or I can say the elements with D1 configuration, D1. How many elements are having their D1 configuration? So that if you understand D1 configuration, so that you can write down configuration of all the elements, each and every element's configuration you can write. Remember that. For this, the trick is good cellulose, good cellulose, good cellulase. Everyone say good cellulase. What does it mean? Gadolinium. Gadolinium is having D1, or you can remember God is one. God is one. You can remember like this. God is one. God is number one, or God is one. This has been asked number of times. Cerium. In class 11th, it is given D1, D2 in class 12th. So contradictory. Cellulose, lutetium. Lithium is from D block, and cerium is coming 2 times. Now, out of these, the most important thing is being God, GD. Number of times they have asked, it's D1 configuration. Now, let me come to the actinum family. Actinum. Just see. The trick for this is you and Napoleon are on similar path. You and Napoleon are on similar path. What is the meaning of this? You and Napoleon are on similar path. What does it mean, kids? Uranium, neptunium, curium. This is M, small m, curium. So see, U, neptunium, path. This is thorium. Similar path. Lr, similar path. Neptunium. They all have D1 configuration. Remember that. So you can write down. So they can definitely, they will ask you which one is having D1 configuration. Is it clear to all of you? Now, I've told you that KMnO4 and potassium dichromate, they are strong oxidizing agent. So what they will do? They will oxidize ferrous to ferric. They will oxidize iodide to iodine. They will oxidize stannous to stannic. Are you getting my point? Now, whether this is potassium dichromate A2Cr2 O7 in acidic medium or KMnO4 in acidic medium. They will do it like this. Now, my dear students, if I tell you one thing, remember that most important thing, very, very important thing, kids. If I give you that KMnO4 is given in alkaline medium, now what do you think? It will change your I negative into what? So remember that answer is iodate, IO3 negative, iodate. This question is very, very important question. Very, very important question. It holds a hell lot of weightage. Just keep it in your brain. This is really very, very important. Now, this thing is clear to all of you. Have you understood this much, kids? Is it clear? Is it clear to each and everyone? Is each and everyone is able to understand? And in D block, one more thing is important. That is chromium, molybdenum, tungsten. Their melting point is like this. If I say, if I draw, if you see in your NCERT the diagram of melting point with respect to their atomic number. So if I talk about chromium, molybdenum, tungsten, so they are going like this. They go like this. They come like this. No, they will come like this, in this order. Let me explain what is that. They come like this order. They come like this order. Now, at the peak, who is at the peak? Tungsten is at that peak, then molybdenum, and then chromium. Remember that. How will you learn it? This is melting point order. Melting point, and this is atomic number. Now you must have seen the bulb. Bulb is like this. Have you seen bulb? The filament of the bulb will look like this, somewhat like this filament, and this is made up of tungsten only. Very high, very, very high melting point. Very, very high melting point. I hope that this much is clear to each and everyone. Everyone is able to understand it. Okay? Now, after telling you all these things, my dear students, let me move towards the P block. This much is clear to each and everyone, kids. Now see, these questions you can do at your home. These are the questions you can do it. These are the homework. Number of questions you can see. Number of questions. Homework questions, right? These are homework questions you can see, kids. Already, no, it's not completed. It's not completed. Let me take something more. Just see, kids. For you people, I will do each and everything. What is important? D is completed. F is completed. Now, Baba is going to move towards P block, kids. Are you ready? Is everyone ready? Hit the like button. Make it 700. Make it 700, kids. So these are the questions you can see of P block. I will share each and everything, but before this, let me teach you, kids. Then I will share, then I will go with the questions and what is important in the P block that Baba is going to tell you, right? Are you ready, kids, for the P block? The important things of P block. Show me green hearts. Let me tell you one thing. In detail, P block, already I have taken one session specific for P block in detail, but that much is not required. That I have taken session 1 year back when the syllabus deleted portion was out. That I have taken session, and that was very, very important, each and everything. But today I will tell you P block only concised way, right? Whatever is required, that I will tell you now. In P block, first thing is that how to remember the elements. Try to remember the elements. That is the very, very important thing, kids. If I say P block, if I talk about P block, kids, then I would like to say that here is boron, everyone, because this is very, very important. You have to first keep it in your boron carbon family, nitrogen family, oxygen family, halogen family, and zero group. So first of all, always do one thing. Take a pick in your brain. What's that? Cross, 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 cross. Never forget this thing, cross, cross, cross. Why I'm placing cross, cross, cross? Because there is nothing in the first orbit, second, third, fourth, fifth, sixth, seventh. When I write like this, one thing should come very clearly in your brain. Ask me what? Ask me what's that, sir? Let me tell you what's that, kids. Then only you can understand P block trends. Otherwise, you will lose your marks. Always see the periodic table should be in your brain like this. Now, whenever you are reaching from here, you just remember the D block. If you don't know D block, you can't understand P block. That's why I've told you D block before P block. Because there is S block. If you see hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Now from sixth one, just see from sixth one, the sixth, cesium, barium, S block, La, D block, D block, D block. Now lutetium. Now in between this, there were 14 elements. 14 elements. Do you remember 14 elements? Cerium to lutetium, 58 to 71. So they will cause lanthanoid contraction. Now where is this? Is sixth. This is fifth. Okay. Lanthanoid contraction. They will do lanthanoid contraction. Lanthanoid contraction. What are you writing, sir? Write it properly. I'm unable to understand. Sorry, kids. You are responsible for lanthanoid contraction. Lanthanoid contraction. Now they will be very, very dangerous for next elements. Now FRAC, thorium to lawrencium, 14 elements. Dangerous people, Rutherfordium. Now What they will do, kids, they are going to do a lot of work: boron, aluminium, gallium, indium, helium. Is right? Right? This is sixth. Sir, we are unable to understand. Write down this properly, sir. Sorry, kids. First, second, third, fourth, fifth, sixth. Is it clear? So this sixth is like this. They will meet over there. Now, one more thing I would like to say that is very, very important. That the fourth one. Here, D or D, D and F both are being very, very poor shielding. D and F, very, very poor shielding. Very, very poor shielding. So not only lanthanoid are going to affect a D block element. Science teacher, very crazy man, felt cold at night with cousin. Science teacher, very crazy man, felt cold at night with cousin. They are also having poor shielding. So effect will be over here also, here also. Now boron and gallium and thallium, carbon, silicon, germanium, tin, lead, nitrogen, phosphorus, arsenic, antimony, bismuth, oxygen, sulfur, selenium, tellurium, polonium, fluorine, chlorine, bromine, iodine, astatine, helium, neon, argon, krypton, xenon, radon. Now, my dear students, number of students will be there. Those who are not able to find out their atomic number also. Let me tell you the magic number. First of all, how to write down their electronic configuration. Let me tell you. For example, if I say 7 days and a week, 1, 2, 3, 4, 5, 6, 7. Sunday morning. Everyone say Sunday morning. Say everyone, Sunday morning. Sip, sip. 2 times sip, sip. Then Sunday morning, sip, sip. Then SDP. That P. That P. Or that P. DP. Sundar DP. Now, save DP. Save DP. Save DP. Save DP. Now see how many times what I have done. Everyone. 1, 2, 3, 4, 5, 6, 7. I'm going to tell you the magic numbers. Everyone first say Sunday morning. Sunday morning. Sunday morning. Sip, sip. Now this is SDP. What is S? What do you call it? SDP. SDP is what? Sunday DP, or what do you call it? Let me see in the chat section. Call it something. Let me see. Anyone is having creative mind like Baba? Sunday morning. Very good. Nazim Rashid, Sausi. Sunday morning. Now SDP. What do you want to call SDP? SDP. Super DP. Wow. Set DP. Wow. Mahumini. Sausi. So Super DP. Set DP. Wow. And safe DP. Okay, set DP, super DP, safe DP, but CP, DP should be safe. Sunday morning, sip, sip, set DP, or super DP, but it should be safe DP, right? Let's make it clear what Sunday morning, hey hey, Sunday morning. Sip sip, sip sip. Set DP, set DP or super DP, super DP, then safe DP, safe DP. This is clear, kids. Now, S can have maximum of how many electrons? S can have maximum of 2 electrons. 2, 6, 2, 6, 2, 10, 6, 2, 10, 6, 2, 14, 10, 6, 2, 14, 10, 6. What is the sum is coming, kids? How much sum is coming out? How much sum is coming out, kids? Do let me know. 2, 8, 8, 18, 18, 32, 32. Got it? Magic numbers. You got it. Now, what is the benefit of magic numbers? Let me show you, kids. If I say helium, neon, argon, krypton, xenon, radon, we know that their atomic numbers are how we got the atomic numbers. If we don't know their atomic numbers, just see to add 2, 8, 10. Now to this 10 add 8, 18. Now to this 18 add 18, 36. To that 36, 36 add 18, 54. Now to this 54 add 32, 86, and whatever the new elements at 32, what new element you will get? 86 plus 32, just see, 86 plus 32, 808. Whatever the element is there, its atomic number will be 108. Got it? Everyone got it? Show me green hearts in the chat section if you liked it. If you liked it, kids. And make it 700 likes, kids. Likes are less. I want likes from your side, kids. Now Baba is going to move. Yeah, 700 it is. You're liking it. Then I want to see green heart. Wow, that's really awesome. Really awesome. Really awesome. Now see, kids. So why I have told you this thing? So you can write down anyone's electronic configuration if you remember this. Now, this will be most affected: boron, aluminum, gallium, and thallium. The expected order of the size is like this. Let me take another page. Expected size, expected atomic radii, expected atomic radii is like boron, aluminium, gallium, indium, thallium. But this is wrong, kids. Examiner will give you big 0 for this. Big 0. Why? You know that due to the contraction and anomalous behavior of d orbital contraction and lengthenoid contraction, the size will be like this. B, G, A, L, indium, Gallium. Now see, the size of gallium and aluminium is approximately same. Approximately same. This was not supposed to be like this. The size is like this, kids. The size is like this. Now, how they are same? Just see, they should not be same, but they are same. Just see over here. Boron, aluminium and gallium. Gallium is in 4th period. This is in 3rd period. This was expected to be having more size, but that is having more size, or they are approximately equal. So why the size got decreased? You just focus over here. There was nucleus, and the nucleus was putting force of attraction, but the d orbitals were diffused. D were diffused, and they were not able to stop the force of attraction, and the force of attraction gone straight away, and that's why its size got decreased. And this was original size, but its size got decreased due to diffuse D, poor shielding of D. So how will you remember this? So remember Bengal in Thailand, or any other trick you can make yourself. Bengal in, this is thallium. Bengal in thala. This is okay. Bengal in thala. Atomic radii. Bengal in thala. Bengal in thalli. Okay, is it clear? Now let me see in the chat section. Is it clear? It's only half an hour I like to take. It will get completed. Thailand, Bengal in Thailand. This is good, kids. Do let me know in the chat section. Is it good or not? Hey everyone, do let me know. Is it okay? Wow, thank you, Ipshita, Kausi. Very good. Now, once the size difference is there, definitely ionization energy will also be getting different. Because of this, there will be difference in the atomic radii. Ionization energy. What should be the ionization energy? So remember that boron, boron, gallium, aluminium, no, gallium, aluminium, indium. So this is the order for ionization energy. Remember that, ionization energy. So how will you learn it? How will you learn it for ionization energy? Bottle Garden, All India. Bottle Garden, All India. So trick for this is Bottle Garden, All India. So these two questions are really very, very important. They hold a hell lot of weightage. Now from the carbon family, you know organic chemistry, but from carbon family, one thing is very, very important. I would like to tell you, what is that? From carbon family, the silicates. So let me tell you trick for silicates. Silicates, very, very important. How many oxygens are common? First, let me explain a bit. Silicates from carbon family. One is silicates, and second thing is allotropes of carbon, that is Buckminster fullerene, saucervolene. But let me tell you silicates. What do you mean by silicates? if I write Si, Cl, 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 and if I do the hydrolysis, so they will become like Si, OH, 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 OH. So H will get replaced, will look like Si, O negative, O negative, O negative, O negative. They can either write like this, or they can write it like this, that if I say this is white point is indicating silicon, and if I say the yellow point is indicating oxygen, so they can write like this is silicate, one oxygen over here, one oxygen over here. Just try to see. Actually, this bond is coming out from what? This bond is coming out from silicon. One bond with that, oxygen, oxygen, oxygen. So these are 4 oxygen negative charge, one more oxygen over here. Just try to understand. They will draw like this. They say that this is tetrahedral structure. So all the oxygens are having 4 negative charge. That means SiO4, 4 negative. So this is known as orthosilicate. I will give you trick also. First let me tell you, then I will give you trick also. Now kids, if they say that silicon, oxygen, 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 and one oxygen is being common, one oxygen is common like this. Just try to understand. Now the oxygen which is common is not having any charge, without charge. This oxygen is being without charge, without charge. So they call it orthosilicate, that one. This is pyrosilicate. They call it pyro. That initial one was orthosilicate. This is pyrosilicate. They can draw it like this, or they can write it like this: Si2O7, 3 and 3, 6 negative. Or they can draw it like this also. Just see, try to understand. They will say this is common oxygen, oxygen negative, oxygen negative, oxygen negative, oxygen negative, oxygen negative, oxygen negative. And in between this, there is silicate. One oxygen is common. All 3 are same. This, all 3 are same. In this way, they can ask number of questions, that how many oxygens are common. What type of question they will ask? Common oxygens. So let me give you the trick. Baba HSP's trick. Just see. Baba HSP's trick. Famous HSP Baba. HSP. Remember that. O P CS, OPCS, OPCS, 2D, 3D, OPCS, 2D, 3D. What do you mean by OPCS, 2D, 3D? Now, O means orthosilicate, pyrosilicate, chain or cyclic silicate, two-dimensional, three-dimensional. Now, the number of oxygens shared. Number of oxygen shared Number of oxygen shared kits. Just see kits. Just see. You can find it out. 0, 1, 2, 3, 4. How's the trick? 0, 1, 2, 3, 4. Only this question they will ask in orthosilicate. How many oxygens are shared? 0, pyro 1, cyclic 2, two-dimensional sheet silicate. Three-dimensional sheet silicates. They will ask this question, kids. Let me have a glass of water. Kids, my dear students. Now in boron, one thing is left, borax. They can ask borax, kids. So show me the green signal if you liked it. If the trick is good, if you're liking it, I want to see the green signal, kids. That's really awesome. Really awesome. Now see, kids. Now in the boron family, one thing they can ask, what's that? They can ask about borax. Borax. What is borax, kids? Borax. You know that borax is Na2B4O7, not 10 times H2O. How many of you forget this formula? Sodium before O7, 7 o'clock. Sodium before sodium, Natu before 7 o'clock. Have 10 glasses of water. First of all, remember this formula. Natu before 7 o'clock takes 10 glass of water. 10 glass of water. 10 glasses of water, right? Now, kids, how to draw its structure? That is very tough. Let's make easy from tough. Na2B4O7, 4 boron. East or west? Everyone say east or west? East or west? B. Now, put O. Let me write down. Now, put OH. Super candy. OH. Okay. What is left? Now, can I do one thing? If I place BOB. Now, kids, this is having 4 valencies. So I have to place minus. So outside 2 Na plus will get neutralized with this twice of Na plus, 2 negative, 2 positive. Now what is left? Just check it out. 4 boron we have consumed. How many oxygen? 4. 5 and 4. 4, 4, 8 and 1, 9. 9 oxygen. How many oxygens are there? 7 and 10. 7 and 10, 17. 17 oxygens were there and we have consumed 9. How many are left? 8 oxygens are left. So can I write 8 times H2O? Now will it get balanced? Let me check it out. How many hydrogens are there? 10 2s are 20, 20 and 8 2s are 16, 16, 17, 18, 19, 20. We got it. Hence balanced. Hence balanced. This got balanced, kids. This got balanced. Just see. Now come to the Nicogen family. Nicogen family. How will you find out what is Nicogen family, kids? Nicogen family. Phosphorus, nitrogen, Nicogen family. Now this is very important. Very, very important. Nitrogen, phosphorus, arsenic, antimony, bismuth. Number of questions will come from here. First thing, that ammonia is having sp3 hybridization. Rest of others, there are no hybridization according to Drago's rule. Without hybridization, without hybridization, bonding is there. Without hybridization, bonding is there. Now what are the consequences of this? Due to this lone pair like this is an sp3 hybridized orbital, whereas their lone pairs, they are in pure s orbital, pure s orbital, pure s, pure s, pure s, pure s. So it's not easy to take there or to attack on their lone pair. They are pure s, 100% about s character. They have their lone pairs. Their lone pairs are having these hydrides of these lone pair is having maximum percentage of s character, so can't easily donate lone pair, so can't easily donate lone pair. So they are not basic in nature, not basic. Why not basic? I have written they are not basic. First thing. Now bond angle, it will get affected. The bond angle get not defected, affected. Its bond angle is 107-degree pyramidal shape, but their bond angle is approximately 90-degree, 94, 93, 92, 91. Now, after this, because maximum will be asked from the tables, whatever the tables they have drawn, maximum will come from that table, and I will make that table very simple. How many of you are interested? Show me the green signal, green hearts. How many of you want that Baba should make that table? All the tables super easy. No need to cram it. You can understand tables very easily. How many of you want it? Do let me know. Show me the green hearts. Okay. To understand that, always remember one point. Bond of equality is good. Bond of equality is good. What is that equality? Means smaller is stable with the smaller. That means if I say hydrogen is big or small, hydrogen atom is big or small, definitely smaller. If I talk about nitrogen, phosphorus, arsenic, antimony, bismuth, so this is a smaller and this is being biggest. Am I right or not, kids? Am I right or not? Right? So this will feel better than this. Good bonding, good overlapping. And it will have weaker bond with this, poor bonding, right? Am I right, kids? First of all, do let me know this is the point to understand or the cramming part. Definitely this is the point to be understand. Now see, kids, if I draw NH3, PH3 phosphine gas, arsenic ASH3, antimony H3, bismuth H3. Now kids, nitrogen and hydrogen, nitrogen to hydrogen bonding is good, means strong bond. Bismuth to hydrogen bonding is weak, poor bond. So if they are asking out of these five, who is better hydride donor? So the question, this is better hydride donor. Am I right, kids? Now, hydride means what? Hydrogen has gone along with electron as hydride. So there is loss of electrons. So who is best reducing agent? This is best reducing agent. So the reducing nature increases on moving down the group. If I say the reducing character increases, right or wrong? Reducing nature and hydride donation capacity increases on moving down the group. Now, my dear students, this much is clear. This much is clear. Clear. If I talk about that who can donate proton easily, if this is clear, if this much is clear, who is good acid? Now, one thing you have to keep it in your brain, that negative charge is more stable. Okay, let me take another page. Acidic strength and basic strength of these compounds. Acidic and basic strength. Now, kids, you have to help me. You have to tell me negative charge is stable on. Negative charge is stable on. I'm asking something. Negative charge is most stable on, is most stable on, fill in the blanks. Fill in the blanks. Most stable on. Do let me know. I want answer. I want answer. Is most stable on. I want answer, kids. Fast. Is most stable on. Negative charge is most stable on kits. I want the answer, then only I can teach you. I can tell you. Negative charge is most stable on. More electronegative. Everyone is saying. Remember that negative charge is most stable on biggest atom. First, we have to see the size. Biggest atom. Never forget. Never ever forget this point. Negative charge is most stable on biggest atom. If the size of atom bearing the charge is approximately same or exactly same, then negative charge is most stable on most electronegative atom. Otherwise, size matters a lot. Keep my point in your brain. Now, this point is going to create the difference. Just see, if I write down nitrogen, phosphorus, arsenic, antimony, bismuth, and if I write down their hydrides, ammonia, phosphine, ASH3, SBH3, BiH3. Now, if it is going to lose its proton, it will become BiH2 negative and it will become NH2 negative. This is most stable. Bismuth is being most stable. So remember that acidic strength is directly proportional. Acidic strength is directly proportional to stability of conjugate base. This you have studied in organic chemistry also. Stability of conjugate base. I hope this is clear to all of you kids. That this is more acidic, good hydride donor, thermally least stable. Bonding of equality is good, so thermally stable. Now, who is better base? Who can donate its lone pair easily? So, ammonia is maximum basic because by just see nitrogen, its lone pair is in sp3 hybridized. How much character? S% character is 25% S character in the lone pair. Now, rest of others, phosphorus, arsenic, antimony, bismuth. According to Drago's rule, there is no hybridization. According to Drago's rule, there is no hybridization. So their lone pair is, you can say, are approximately 100% in having 100% to 94% S character. So whose lone pair can be easily snatched? Proton can easily attack on its lone pair. So the basic strength order is in this way. This is the basic strength order. Clear to all of you kids? Nothing to be cramped. I hope this much is very much clear to all of you kids. Now, Baba will tell you oxy acids of phosphorus because that is very, very important thing. Oxy acid of phosphorus, oxy acid of sulfur. They will definitely come in your exam. So let me tell you oxy acids. Are you ready, kids? Just 15 to 20 minutes more. We'll get over. Oxy acids of phosphorus. Always remember some points, basic points. Higher oxidation state like +4, +5, we will write ic acid, ic acid. Lower oxidation state like +1, +2, +3, we will write us acid. First point. Second point, P double bond O, OH. This much is the basic requirement for an oxy acid. Why? This H is acidic H. Why? Because if it is leaving out, it will form conjugate base, and that conjugate base is stabilized by resonance. Now see, this is doing resonance in between this, stabilized by resonance. And that's why I will tell you who is making more acid. H3PO2, H3PO4, H3PO3, H3PO2, H3PO4 is most acidic, that I will explain, but this much is necessary. Now, if any hydrogen is attached on this place, it's not acidic, not acidic. Yes, the charge will get localized, and this will be responsible for, reducing nature, reducing nature. Now see kids, by keeping all these things in our brain, let me tell you, oxy acids of phosphorus. If I draw like compound like this, P double bond O, OH, OH, OH. Can you see what is the oxidation state of phosphorus? -2, +2, -1, -1, -1, -3 to +3 will come out +5, +5. So this is ic. Its name is orthophosphoric acid. Orthophosphoric acid. Its N factor is replaceable 3H plus, so 3. Now if I heat it, if I take two molecules and heat it, P double bond O, P double bond O. Water will get eliminated out. 100 degrees Celsius. I will get compound like this. P double bond O, OH, OH, O, double bond O, OH, OH, H4P2O7, H4P2O7. Is it visible to all of you kids? Just to let me know. Now we have heated it. Heat means pyro, so its name is pyrophosphoric acid. Oxidation state -2, -1, -1, +4, +5. This is -1, -1, so +5, also +5. Pyrophosphoric acid, pyrophosphoric acid. Now if I remove one oxygen from here, so having less oxygen So P double bond O, OH, OH, P double bond O, OH, OH is the oxidation state. -2, -1, nothing. So +4, +4. Oxygen is less, so we will say hypophosphoric acid. Now, if you directly heat it, that at very high degrees Celsius, 600 degrees Celsius, water will get snatched and you will get P double bond O, OH, coordinate bond O. This is highly unstable, so it will trimerize HPO3 whole thrice. It will polymerize HPO3 whole N. Oxidation state is +5 metaphosphoric acid. Now, if we remove oxygen from here, it will be like this: P double bond O, OH, OH, and H. And hydrogen is there, so N factor is only 2. We'll say it is H3 PO3, orthophosphorus or phosphoric. Just see, -2 to +2, -1, -1, -2, +1, so -1, +2, -2 cancelled out, -1 or +1, +1, -1. How it is coming +1? Check it out. -2, +2, minus, 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 so +2, +2, +2, +4 not got cancelled out, sorry. So -1, -1, so +2, this is +1, so -1 got cancelled out, 3, 3. So 3 will say orthophosphorus acid, orthophosphorus acid. Now this people call it with the nickname phosphonic acid, phosphonic acid. Now if I remove one more oxygen, you will get P double bond O, OH, H, H. This is known as hypophosphorus acid. Why phosphorus? -2. So -2, -1, -1, -4. So +4, +1, so -1. No, no, no. What is this? See, this is -2, -1. This is hydrogen. Can you see hydrogen, kids? Hydrogen is +1, +1, -1. So -2, +2, -1, +1, +1, -1, +1, -1, -2, +2 cancelled out, +1, coming out +1. So hypophosphorus acid. People call it with the nickname phosphonic acid. Phosphinic, that is phonic. This is phosphinic acid. Phosphinic acid. Oh my God, kids, I was busy with that. Let me check it out whether it is visible or not. Whether it is visible or not, kids, do let me know in the chat section. Everyone, kids, Baba wants to know that is it visible or not? Is it going to help you a lot or not? This is really, Baba is telling you number of things, really worth watching it or not. Show me the green hearts if you are really loving this. Now, thank you, kids, thank you. Now see, kids, Now see, let me show you the magic. Let me show you the magic that P4 phosphorus reacts with oxygen, catches fire. Now phosphorus, if I tell you the oxidation state, can show +5 and +3. So P2O3, and it can form P2O6. They will get dimerized. P4O6, P4, something I have written wrong, P2O3, P2O5, P2O5, P4O10. First thing, their structures, and then their hydrolysis. First, let's see the structures. P4O6, 4 phosphorus, east or west, phosphorus is the best. PPP. What should I do? P4O6. How to write down structure kits? Pop. Papa has become pop. Pop, pop, pop. Pop, pop, pop. Pop, pop, pop. Pop, pop, pop. Let's see pop, pop, pop. POP, 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 POP. Now, how many oxygens? 6. So what I can do now, kids? POP, I can write like this. And POP, I can write like this. What I will get? Now, all the phosphorus for P4O6 got completed, I think 6. 6 got completed, valence is 3. So I will write its lone pair is like this. Now they can ask about the lone pair or the POP linkages. Now they can ask. Now let me tell you P4O10, how to draw P4O10. Now east or west, phosphorus is the best. Now POP, now POP, now 10 means 4 oxygens extra, double bondo, double bondo, double bondo, double bondo. Now if they are asking lone pairs, here lone pairs you can calculate. P is having 4 lone pairs, oxygen is having 1 oxygen is having 2 lone pairs. So 4 lone pairs and 2, 6, 2 are 12. 4 plus 12, 16 LP, right? Now in this, there is no lone pair on phosphorus. So 10 into 2, 20 lone pairs, right kids? Is this clear to all of you? Show me the green hearts that if you are able to understand, do let me know kids. Very good. Shaban Aziz, that's really fantastic. Going on, West going on, see kids, that's really fantastic. Now, what they can ask more, what they can ask, see. If I tell you, my dear students, I'm having HPO3. What I'm going to tell you, just understand. I'm having H4P2O7. I'm having H3PO4. In all three, what is common? What is common in all these three? A, B, C. Can you let me know what is common in all these three? Do let me know, kids. What is common in all these three? No one? Hey, everyone. What is common in all these three? No idea. Oxidation state. All they are having what? All they are having plus 5 oxidation state. All they are having what? Plus 5 oxidation state. Can you see, kids? Plus 5. All they have strong affinity for water. Let me check it out whether I may right or wrong. If they all are having a strong affinity for water, then what I will get? No, kids. This is very tough to understand. Let me tell you in a better way. In this way, you won't be able to understand. Let me tell you in another way. Then I will come to this point so that it will become easy. Otherwise, in this way, it's not easy. It will be tough. First of all, let me take P4O10. What is the oxidation state? Plus 5. Now, P4O10, if I add water to this, can I get H3PO4 or HPO3? Because the oxidation state is common. So I think I should get this because I've written oxidation state remains constant. So 4 phosphorus, 4 phosphorus. Now hydrogens are 4, so 2 times oxygen 10 and 2, 12, 12 balanced. One more reaction, let's see. P4O10 plus water. If I say that H4 P2O7, here also plus 5 oxidation states. I am supposed to get this also. 4 phosphorus already 2 hydrogens, 4 2s are 8, 4 oxygen 10, 4 14, 7 2 balanced. One more reaction, let me write down. P4O10 plus water. If I say that H3PO4, here also the oxidation state of phosphorus is same. So P4, 4, 4 3 are 12, 6, 10, 6, 16, 4 4 are 16. Now, what I can do, 2 and 4, so I can add here 2 times H2O, or I can add here 4 times H2O. I will get same thing. Can you see? Now it's easy or not? You are liking it? Do let me know in the chat section. Yes, it's really awesome. It's some people are writing, you love this, you love that. It's you don't know who is girl or who is boy. Why you are wasting your time? In the chat section, how will you understand who is boy or girl? There are fake IDs. You are really not having brain. Without understanding whether that ID is having boy or girl, you have started playing love, love, love. Such a fool, people. Can't understand. You can be like this much fool. Really. Can't understand. Now, it's what to say, what to say. Really, people are really what to say, no words. Now, kids, now let me move towards oxygen and then halogen, right? Oxygen and then halogen. Sir, inorganic chemistry, what is writing? Ayushi Vardwaj. Oh, inorganic chemistry is so boring. Hey, Ayushi Bhardwaj, I think you have not gone through the whole. Yes, spammers are there. Start showing green hearts. Shakti is right. Spammers have come. Ayushi Bhardwaj, I think you have not gone through the whole chapter, whole lecture. Otherwise, you would not have said like that. Baba's class. You have gone through each and everything. सब कुछ याद होगा बेटा. Just attend my classes. You will be able to understand each and everything. Okay. Now, after this, now let me tell you how to make equations. Let me come to halogen. Let me come to halogen and now see. First, I will give you question, right? Question. Now, let me show you, Bhardwaj, how to understand inorganic chemistry. Question is, which reaction or reactions are feasible is are feasible. I will write 4 equations, okay? Then I will show you the magic. Just see to it and do let me know. I will see your comments. Let's see how many of you can do this. Let me check it out. Write down. I'm watching your comments. How many of you can do this? Prashad Mahamuni is going for AB. Let me see whose answer is going to be correct. Then I will show my magic. FF old player is going for AB. Rose started giving Rose. Okay. Ayushi Vardwaj is going for A. Thank you, Gaurav Kangar. Badri J is going for B. Let me see who will give the correct answer, kids. Till now, everyone's answer is wrong. Till now, everyone's answer is wrong. Let me check it out who is going to give the correct answer. Laddu Yadav, thank you. So nice of you. Tausi is going for D. Wrong. Tausi is going for all of these. Wrong. Till now, no one. Ananya is going for C. Wrong. One boy is going for BD. Wrong. So till now, everyone is wrong. Now, it's D. Wrong. Sabah Nazir. Now, see kids. How many of you want to know the concept? And then I will come back to the same question. How many of you want to understand the concept? Show me the red hearts, red hearts. Then I will tell you the concept and I will come back to the same question. I will come back to the same question. Show me the red hearts fast. One line of red heart. Make flag. Make flag. First. Let me check it out. Let me check it out. Okay. Now, Baba is going to tell you one scientific story. Just listen to that story. Scientific story. In a jungle, there was potassium in a jungle. Potassium was always thinking of donating one electron, donating one electron. One day, potassium has seen iodine. Hey, iodine, how are you? Iodine said, I'm good. What's about you? I want to donate one electron. Iodine said, oh my God, I want to accept it. So he has donated one electron and iodine has accepted one electron. So after donating electron, K was like this, iodine was like this, and they have developed force of attraction. Hey, I love you. Hey, I love you. They can see, they can understand they are having opposite charges. But why you are doing so in the chat section? You can't see each other. So this bond, hey, what do we call our relationship? This relationship will be known as by the name of ionic bond. Okay. Then what happened? Chlorine has seen this thing. Chlorine has seen that they are bonded. Iodine has taken electron of this potassium. Chlorine said, hey, I'm being more electronegative than you, iodide. Chlorine has given one tight slap. Kichak, kichak, kichak. Give me this electron out of me and you. Who is being more electronegative? Iodide said, oh, you are more electronegative. So has taken electron and displaced iodine. Right or wrong? Right or wrong? Right. First story. Story number 2. One day there was potassium. Chloride came. Hey, chloride, how are you? I'm good, I'm good. Let's form a bond. A positive, Cl negative. And then iodine reached. Now what iodine, is it possible that iodine can snatch electron from chloride? Is it possible? Just to let me know in the chat section. Let me see the fact of story. Is it possible? No. Sabah Nazir, very good. It's not possible. No reaction. Now two stories. After these, third story. Let's see story number 3. One day, potassium was in the jungle. Chlorine came over there. Potassium donated 1 electron and chlorine accepted 1 electron. They started living happily, called as K positive, Cl negative. But iodine came. Now what will happen? Just to let me know what will happen in the chat section. Fast. Write down fast, very fastly. Iodine came. Hey, I will snatch your electron. I will snatch your electron. What will happen? Just to write down. Nothing will happen. But oxygen came. Now what will happen? Oxygen said, hey, I will snatch your electron. I will snatch your electron. Now it has formed ACLO. Now chlorine started crying. I'm plus one. I'm plus one. It started crying. Then oxygen called his brother. Hiya, brother, hey bro, Anna bro, come here. Chlorine is having number of electrons. So oxygen called one more oxygen. Now they formed KClO3. Now KClO2, KClO3 like this. KClO2 plus 3, KClO3. Oh my God, plus 5. Now chlorine started crying. What happened to me? Why this happened to me? I can't snatch electron from oxygen. Now, one day, there was iodine. Iodine approached there. Now, oxygen already snatched, no oxygen. Now, chlorine will say, hey, iodine, you are less electronegative. I will snatch electron from you. You just come over here and be over here, and I want to get rid of this oxygen. I will go outside. Now you are able to understand the story, that what's the difference here. Chloride is having -1, can't give electron, but here chloride is having +5. So iodine is captured over here. Can you see the difference? How many of you have seen the difference? Show me the green hearts if you have seen the difference. If you have understood, you have noted down the difference. Show me the green hearts. I want to see the green hearts if you have noted down the difference. If you got it, kids. And I will go back to the same question, but first of all, I want to see the green heart. Very good. Very good. Ipshita Sahu is there. La Mathi is there. Nan is there. Everyone. Okay. So let me see. And let me go for the question. Now answer it. Now whether you are able to answer it or not. Now just see properly the question. Properly see to it, kids. Everyone, do let me know. This is the question only. Oh, what happened? This is not the question. Sorry, kids. Where the question has gone. Yeah, this is the question. This is the question. This is the question. See, now let me know. See to it properly, kids. See to it properly, kids. Thank you, Coffee and Neat. No, no, see to it properly, kids. See, no, what are you doing? Kids, see to it properly. You are not seeing. What are you doing, kids? Yes, some people are able to get it. Ayushi got it. Prashad got it. Sabah Nazir got it. B and C. Very good. You got it. You're rocking. C. C. This is -1. More electronegative. Not possible. This is here +5. It will come over here. KiO3 and Cl2 will get rid of that feasible answer. -1, this is more electronegative. So it will snatch electron from here. It will be twice of KCl plus I2. It is also possible. This is +5. Cannot snatch electron from there. B and C. Kids got it? Baba has not told you the answer. You got answer from your side. Everyone, you got answer from your side or not? First of all, do let me know how many of you are feeling happy that now you got it, how to do the questions. Now I want to see in the chat section how many of you got it, that really this is the way how to solve the question. Kids, show me the green hearts. Everyone, do let me know. Kids, I want to understand that how many of you are now feeling, yes, this is the way. Now you are able to understand how the things are possible. Pravalika, yes, yes, yes. Now 10 minutes more, kids. Only 10 minutes more. The class will get over. Just 10 minutes more, okay? Just 10 minutes. So this is the way how to solve the question. Now, kids. Halogens. Halogens are derived from C. If I talk about chlorine, chlorine, bromine, iodine, out of these four, who is having maximum SOP value? The SOP value, standard oxidation potential, increases like this. Maximum SOP. SOP means standard oxid, no. SOP, no. SRP. Maximum SRP, standard reduction potential value. Now, this is maximum reactive also. For most electronegative, if I say fluorine is there, chlorine is there, bromine is there, iodine is there, maximum electronegative, its electronegativity is 4.0. But who is having maximum negative electron gain enthalpy? So the answer is chlorine will have maximum negative electron gain enthalpy. Am I right, kids? Now, what is the difference between electron gain enthalpy and the electronegativity? Electronegativity is just the temptation towards electron, and this is once the electron has been taken. Once the electron has been taken and whatever the amount of energy has been released, that is known as electron gain enthalpy. Now the bond dissociation energy, let me tell you, kids, bond dissociation energy is in this order. This is bond dissociation energy order. Now, my dear students, why the bond dissociation energy order is like this? Let me explain. This is chlorine, this is chlorine. They are having lone pair, lone pair, lone pair, lone pair, lone pair, lone pair, lone pair. Now, if I say this lone pair is in 3p, this lone pair is in 3p. Now, you can see very clearly its 3D is vacant. Its 3D is vacant. So, the electron will play back bonding, back bonding. You can see back bonding, back bonding. 3p to 3D, 3p to 3D. Can you see, kids? They can do delocalization, and due to this delocalization, bond strength will increase. That's why this is bond dissociation energy order. Now, question arises, why this is having maximum standard reduction potential value? Why this is being best oxidizing agent? This is all because of hydration energy. Its hydration energy is maximum. Ionization energy is not less, but its hydration energy is maximum because water loves smaller ions maximum. So the hydration energy of fluoride is maximum. That's why this is the reason this is going to be the best oxidizing agent. Is it clear to all of you? Are you getting my point or not? Everyone, you are able to understand it or not? So kids, this is all for today. I've told you the whole coordination chemistry. I've told you the whole DNF block elements. Now I have told you the whole P block, which is expected for your examination. Anything if you want to ask, then you can ask me. Otherwise, each and everything I've taught you, kids, this is all for inorganic chemistry. And questions will definitely come from here only. So bye to all of you, kids. And I have not left even a single thing. I've gone through, you have seen that Baba has gone through each and everything. Baba has explained each and everything, kids. Each and everything I've touched, I've gone in detail, even the John Taylor distortion. I've gone through the trans effect, which is not given in NCRT. And today I was not feeling well, kids. But then also, you can see, you can understand, I taught each and everything. I've gone through each and everything. And I tried my level best to tell you each and everything. Bye to all of you. God bless you, kids. Love you, kids. Stay blessed. Almighty God, help these students. Please, God, it's my prayer to all of you that all these students should get best rank. Best rank. Bye to all of you, kids. Bye. Bye. God bless you. Love you, kids. Thank you, Babita. Thank you, Laddu Yadav. Saba Nazir. Pravalika Chatu. Thank you. Madan. Thank you. HSP. HSP. Thank you, everyone. Karthiodorek. Monisharaj. Karthiothoracic. Ilamithi. Thank you. Sausi by Dinan by Monisharaj by Pravalika. HSP means Harendra Singh Parihar. Pravalika. Hari plus Indra, Harendra Singh Parihar. Kalyan Deepak bye. Monisha Raj, Aksha, Gautam Srija, bye to all of you. JK bye. In the world bye. Partho Thorakic, same here. Axa bye. Nandini beta bye. Nandini bye. Gautam Sirja bye.